क्या हो गया? ऐड बंद हो गया।
हेलो, चेक करना। हेलो 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 हेलो, लाइव है।
आगे। अच्छा ये ठीक है, ओके। ठीक है। Good.
Good morning, everyone. Welcome back. I hope you had a good poster session and interaction. We'll start with our next technical session, which is on aquatic ecology. The session will be chaired by Shri S. Saseri and co-chaired by Dr. K. Shivkumar and Dr. J. Johnson. And the session facilitator will be Ms. Chitmaya Ghanekar. I request
To Uttarakhand cadre. So he has served in Uttarakhand state in various capacities. He was the former director of Rajaji Tiger Reserve, director of Nandali Biospheric Reserve, and there was a member secretary biodiversity board Uttarakhand. So it's a great honor to be here actually. In fact, he's very keen interest on aquatic species, especially fishes and other lower taxa. So it's the right person to chair this session. I welcome you, sir. Next, we have a co-chair, Dr. Shivkumar. He is known to many of you. Currently, he is a professor at Pondicherry University. He served in this institute more than 20 years. He started his career from Nicobar group of islands, studied the ecology of the megapode, and he has worked on a variety of wildlife, including aquatic system, marine and the freshwater system. So, welcome Dr. Shivkumar. And we have facilitator Ms. Chinanga Aquatic. So, with this few words, now we can start the aquatic ecology session. So, we have 5 presentations. So, now without taking much time, I will invite the first speaker. I invite Ms. Swapnali Gole. She will be talking about the Dugong conservation in India, a review of progress and way forward.
Swapnali Gole is a marine researcher, a scuba diver, and a National Geographic explorer. Since last 9 years, she is studying marine ecosystems in Andaman and Nicobar Islands, including intertidal ecology, polyfluvial biology, marine symbiosis, dugongs, and sea grasses. Over to you, Swapnali. All the best.
It just कौन से फोल्डर में है सेशन 3 है सेकंड में Thank you, Chinya, and a very good morning, everyone. Dugongs for a long time have survived to say they would spot a dugong and think that it is a mermaid. That is how dugongs got their very common name, that is siren meaning a sea nymph, and that is why dugongs along with manatees are also placed under the order Siphonia. So, dugongs is an exclusive marine mammal species which feeds on seagrasses, and it has a wide distribution range across 42 countries including India. But one common scenario for all the distribution ranges of dugongs is a global population decline due to the aforementioned threats. And the fate of Indian dugongs was no different, because historically dugongs were found across the peninsular coastline of India. But with time and the increasing threats, the population was declined so much that it is at present now restricted to only 3 pockets in India. So this is why the government of India intervened, and we came up with the government of India came up with a recovery plan a task force for conservation of dugongs, and which also charted out the national action plan of dugongs for dugongs in India. And this, the implementing agency for this was chosen to be WIR, which is why in 2016 the Campa Dugong project came into picture. I'm going to start my talk with this slide because this was our last slide in ARS 2019 that we had requested to everyone that we need time because Dugong project was still a baby project and we only had presented our preliminary results back then. I am happy to share that in the last couple of years, the milestones which we have achieved has changed the narrative of Dugong conservation in India, and the next couple of minutes will be all about it. The broader components of our project are research and monitoring, sensitization and capacity building across the three distribution sites of dugongs in India, that is Gulf of Kutch in Gujarat, Pathway and Gulf of Mannar in Tamil Nadu, and the Andaman and Nicobar Islands. Under the research and monitoring, that is the first objective, the major objective of our project, we have been looking after the dugong habitats, that is sea grasses, because as I mentioned, they are exclusively herbivorous marine mammal species, along with understanding which are the key areas where dugongs are found, that is, which are their distribution hotspots. And from management point of view, the last objective is critical, where we have tried to assess which are the threats to these habitats, collectively giving critical dugong habitats in India. So for the first objective, that is sea grasses, wherever a suitable substratum for sea grasses is available, sea grasses will grow there. So how would we know that some meadows are important to dugongs and some are not? Because dugongs have a unique feeding behavior where they either nibble the shoots or they uproot it completely. They happen to leave something called as a dugong feeding trail behind. So in a seagrass meadow, if you are surveying 10 seagrass meadows and if you find these trails in 5, this is a direct visual cue and evidence to know that this particular area is used by dugong as a foraging ground. So when we did seagrass surveys, we tried to map the seagrasses along with looking for these visual cues in the meadows, for which a combination of different methodologies was used, because we have to understand that we are talking about 3 different sites with very different local environment here. So standardized methodology cannot work across the 3 sites. For intertidal meadows, we did on-foot exploration using quarter sampling. If it is a subtidal meadow that is always submerged in water, we use either scuba diving if the water is clear or grab sampling, and along with that, advanced tools like remote sensing and GIS. For the second objective, to delineate areas which are used by dugongs on a regular basis, there were 2 issues. The first was, subsequently we realized that feeding trails are always not visible. So if your meadows are intertidal, they are exposed in low tide, you can see feeding trails if the meadow is continuous. But what about the areas where the meadows are largely subtidal in nature, always submerged underwater, and the water is turbid like parkway, where you cannot see beyond 2 meters. Here you cannot see the continuity of a feeding trail in the meadow. Also for places like Andaman, where water is clear, but the habitat is so discontinuous that seagrasses are patchy naturally, you will not know what you are seeing is a feeding trail given by dugong or the natural pattern of seagrasses. So we needed a different approach to understand the hotspots for dugong and not just rely on feeding trails as visual cues, which worked very nicely for our Gujarat team because we have intertidal intensive meadows and we have more than 800 feeding trails recorded from Gulf of Kutch. Another issue with dugongs, the time of dugongs is hardly 1 or 2 seconds. So if we happen to miss this sighting, we don't know how much when our next direct encounter with dugongs is going to be. So we came up with 2 innovative approaches to understand which areas are critical for dugongs occurrence. The first was community participation, where we created a citizen science network, and we also did social surveys with exclusively targeting local fishermen. And the second, as my colleague Sagar already has mentioned, we use drones to understand if we can have detections of dugongs in our respective study sites. For community participation, these were the major stakeholders we targeted. So no matter what the stakeholder is, the only criteria for having being a part of our marine citizen science program was you needed to be a regular seafarer. So all these stakeholders which we targeted were regular seafarers. And in drones, we use systematic samplings to see if we are getting detection of dugongs. Because this was the first study using drones in India, not just in Dugong project, we kept our pilot surveys restricted to the already identified critical areas in 2013. And it was not done across all the study sites because of this reason. Lastly came threat mapping, because this is the most critical part of the work, where we also asked our informants to give us stranding records and did systematic threat surveys. So what would we do? Now we have all the objectives achieved, which resulted in our key achievements, and we also were able to give management recommendation to for the critical dugong habitats. Starting with Tamil Nadu, as a response to our massive sensitization program at grassroots level, we have received 77 stranding records till date. And what is interesting here is there is an increase in stranding reports as a response to our sensitization programs at grassroots level. When we digged more into the month-wise trends of these strandings, we also realized that January and June is a peak of stranding in Tamil Nadu, which also aligns with change in the ocean currents. I'm talking about monsoon and post-monsoon, retreating monsoon change in winds. And most critically for June, in April and May, there is a ban on fishing, especially trawler fishing in Tamil Nadu, which is uplifted in June. So collectively, the pressure of fishing again is a lot in this particular month. But not just that, we just did not get increase in standing reports. We also got standing entangled rescues, which is just rising each year, which is one of the key achievements. And seeing the trends, we suggested that the northern parkway area is very critical for dugongs, because the standings and light sightings also are concentrated in this region because of good availability of seagrasses. Here in 2019, WI suggested that this area should be declared as a conservation reserve because even the threats intensity is quite higher in these areas. And in 2022, we got our first victory as a dugong team, because 448 square kilometer area delineated by WI was declared as India's first conservation reserve. So our management suggestions for this area are regulation of fisheries, and also an emergency response team needs to be created where our responders are trained enough to handle strandings. Story from Gujarat was different because in 2016, Story in Gujarat was different because in 2016, WI was time and again criticized on why WI is wasting money in Gujarat. There are no dugongs left there. In 2018, our team gave the first hope of dugongs in forms of 2 standings, where if taken a close look, even on these slides, a detailed necropsy was done, and the marks on the body of these dugongs was an indication of something more that we did not know before. These are rake marks generally given by dugongs using the tusks, and they generally are high in activity during the conspecific behavior, which is reflected in the courtship, during the courtship time. So these rake marks was the first evidence that there is a breeding population of dugongs in Gulf of Kutch. After that, a thorough investigation of seagrass meadows from the region gave us our 15 foraging grounds mapped for the first time from Gulf of Kutch, where people initially were saying there are no dugongs left. And more than 800 foraging trails have been reported so far. This is the first seasonal study on foraging behavior of dugongs in Western Gulf of Kutch, where our dugongs have shown site fidelity to the mapped areas. Also, our community is obsessed with photographs. So this is the first photographic evidence that there are dugongs in Gulf of Kutch. Management recommendations, as you can see in the map, because most of the foraging grounds in Gujarat are protected inside the core area, they are to some extent protected already, but the red areas are around Bay Dwarka, where there is a high influx of tourism. So here we recommend that the normal anchors which fishermen and tourist boats are using should be replaced by screw mooring anchors, which are which are eco-friendly, because the normal anchors also tend to damage the meadow by meadow scarring, which further deteriorates the health of the meadows. In Andaman, the story was different because we always had a baseline. First by SACON, next by NCF. The pressure which we had there was to do something new. Dugongs were always reported from the islands. The threats were always reported from the islands. After tsunami, it was also said that the social system of dugongs in the islands is broken down into solitary individuals and in pairs. Did we have a different narrative to give? Yes. Because after 40 years, we have reported dugong herds from the islands. And the largest herd which was given by our informant, it is an officer from Indian Coast Guard, is of 13 individuals, telling about the stability of population in this area. And yeah, we also have received sightings from data deficient regions, that is tribal protected areas, which are very prevalent in the islands. We have been monitoring 3 individuals since last couple of years, and they have shown site fidelity to the foraging grounds we have mapped. Management recommendation in the islands, the threats are localized, so we request the management to focus on Reti's archipelago and South Andaman, which are high tourism areas, and a top-down approach here is needed for the boat speed regulation, especially because we tried the bottom-up approach and it did not work. Ours is the first team in India to use drones, and we have been able to give successful detection from the studied sites. This is a particularly interesting slide because, as you see, our 7 years boat-based sightings are 20 collectively for 3 sites. For drones in 1 year is 99 and more than 1,000 sightings because of our citizen science network. So we suggest that citizen science is a very effective tool when it comes to studying low population species like dugong, which have habitats like the vast sea stage. As a result of our N number of sensitization programs, we have done more than 900 programs till now, and around 1 lakh people have been sensitized. The key flagship program which we have under the project is Dugong Scholarship Program, where more than 1,000 children from the fishing communities have been given financial aid, which is 500 rupees per month, and which has been very well received across the 3 sites. In 3 years back, when the whole world came to a standstill in the COVID lockdown, even our sensitization programs were at standstill, and we started something called as the World Dugong Day, which became a massive social media hit, and it was then picked up by different forums. And this year, we took our project to a global forum where we invited all international dignitaries and discussed what are the updates of our project. The last key achievement of our capacity building program is marine mammal stranding workshop, which was very much required as we have seen how the trends of strandings were in Tamil Nadu. Here, all the trained people further trained the capacity of forest staff and veterinary doctors, which are the first government entities to go and report to any stranding report. So here, we targeted the range forest officers and veterinary doctors across 8 coastal states. For the first time in India, a marine mammal stranding manual has been released where we have given in detail on how the stranding response should be using standard scientific protocols. The way forward is we would focus on using high-end drones because right now what we used was a short-end drone. The range was around 3 kilometers, which will give us the population estimation in the coming years. Continuous engagement and strengthening of stakeholders is extremely important because every time we go back to field, the DFO has changed, the commanding officer of Navy has changed. So the project, even if it is of 7 years, we have been re-engaging people from zero every season. And it is a task because the receptions which we get from changing officers is always not the same. So our sensitization and community building, capacity building programs are a never-ending process till the project is on. And also we will create a stranding response team, a mobile stranding response team, because here, especially the reason why mobile word is used over here is because they will be like the first entities along with the department, like they will be a part of the forest department people only who will be training, and then using the standard protocols which we have given, they will go and deal with these strandings. The last way forward would be understanding social structure, demography and behavior of dugongs using all the techniques collectively which we have used. I would want to conclude my talk in this ARS on a note that the baby project which was considered in 2019 has grown up now beautifully along with other species of campas also, and we still need more time because conservation is not a one-time thing. In one phase you do something, in other phase you target something else. So we definitely need a second phase for the Campa Dugong project. With that, I would like to acknowledged Tampa, Wildlife Institute of India. Special thank you to the state forest departments for their immense support for all our teams and all our stakeholders and especially the local communities for believing in our cause and never stopping it. So a big thank you.
Next, we will move to the next presentation. I invite Dr. Shivani Parpor. She will be talking about planning and management for aquatic species conservation and maintenance of ecosystem services in Ganga River Basin for a clean Ganga.
Shivani.
Shivani Bartwal is a master's in forestry and holds a PhD in wildlife science. She is currently working as project scientist in NMCGWI project. Over to you, Shivani.
Thank you for introduction and very good morning to this August and Learn gathering here. We all know the dire status of biodiversity in the ongoing Anthropocene. Thank you. So we all know the dire status of biodiversity in the ongoing Anthropocene. The decline in biodiversity, however, is not similar across the ecosystems. As is seen in the graph, the decline of freshwater species is at higher rate than of the marine or terrestrial counterparts. In fact, the freshwater populations have declined by 83% compared to 69% over last 5 decades. What is the cause of this decline? For river ecosystem, the foremost cause of this decline is loss of habitat, and loss of connectivity contributes to loss of habitat. Grill et al. Studied large rivers of the world and found that only 37% of them have remained free-flowing over the entire course. This loss of connectivity is a major issue for freshwater biodiversity. How do we bend the curve of this decline, and how should we go about having an emergency recovery plan? So Tickner et al. They came up with 6 action points for recovery plan for freshwater ecosystem, which range from accelerating implementation of environmental flows to safeguarding and restoring freshwater connectivity. But how do we go about for an emergency recovery plan for human-dominated river basins? In human-dominated river basins, the recovery plan has to be integrative and consultative. They should be based on the principles of ecological restoration, that is, river should be healthy and dynamic, ecological conditions of the river should have measurably improved, and the rivers which are restored should be resilient to external disturbances. Also, we need to identify and acknowledge the linkages between hydrological connectivity and ecological processes as we devise the emergency recovery plan. And for most, we have to also consider social and economic constraints, particularly in human-dominated river basins. However, river restoration or this emergency recovery plan, they are marred with numerous of challenges. First of all, there is limited understanding of stock and flow concept and the ecological processes. There is also a limited understanding of river biota. There is lack of temporal and spatial replicates to help in conservation decisions. And further, climatic variables, they pose further challenges, particularly in high biodiversity, highly human densely populated regions where water resources or river resources, they have conflicting uses and which are acted upon by multi-sectoral policies. The Ganga Basin represents such challenging basin where we have, at one hand, it holds about 650 million people of India, which covers 40% of India's landmass. And on the other hand, apart from the megafauna, which is terrestrial megafauna, tigers and leopards and elephants, it has numerous aquatic species such as 2 species of dolphin, 3 species of otters, apart from numerous species of water birds and 3 species of crocodiles. For the Ganga Basin, we had questions in our mind that what is the present status of river habitat? What is the state of flow of river vis-a-vis distribution of important species? Which stretches has high biodiversity in terms of species of conservation significance? And are the existing protected areas enough for conserving these aquatic species? Another question, key questions were, how do we involve 650 million people who reside in the Ganga basin? So with this question, we initiated first phase of the project, biodiversity conservation and Ganga rejuvenation in the main stem of Ganga River from 2016 to 2019. We got answers to some questions, but we realized that without considering or without answering these questions that were asked earlier for the main entire basin, our process will be incomplete and we will not be able to have conservation planning for the aquatic species. And today I will be talking about the second phase of the project on behalf of my project investigators and our team of 113 research persons. The project, it aims to develop a science-based aquatic species conservation plan for the Ganga basin by involving multiple stakeholders. We are achieving this through 6 components which are interlinked and which complement each other. The first thing that we did was to collect the ecological data. We did continuous river surveys either on boat or foot depending on the feasibility. We collected information on river hydromorphology, water quality parameters, species presence, as well as anthropogenic factors. Then we plotted species distribution on spatial domain, and we found that Gangetic dolphin was present in 13 of the 20 tributaries studied. Otters, they were found in 5 tributaries, mostly along the protected areas or least disturbed areas. Gharial was found to be present in 11 of the 20 tributaries studied. Mugger was found to be present in 13 tributaries, whereas turtles and waterbirds were found almost throughout all the tributaries. We plotted all these together to get biodiversity hotspot, and we found that 40% of the Ganga basin has high biodiversity stretches, or where species assemblages is multi-species. We also plotted anthropogenic activities, and we found that cremation ground, drains, ferry boats, fishing and sand mining and water extraction were rampant throughout the Ganga basin. During the ecological survey, our teams also reported they recited some of the rare species and also cited the nesting colonies of some of the species. For example, Himalayan bull snake was reported after a gap of 112 years from Ton's Valley. Apart from this, we also studied pollution and ecological risk assessment in 12 tributaries of the Ganga basin. We examined water quality parameters and also studied pesticide, heavy metals, and other pollutants in the river. Based on water quality parameters and heavy metal concentration, we found that Chambal River, Kosi River, Gandak River, Son, and Ajay, they were low-risk zones, whereas some stretches of Yamuna River, Ganga, Gomti, and Ramganga, they were under high-risk zones. Based on flagship species approach, we identified areas for conservation priority stretches. We found that 40% of these tributaries were suitable for Gangetic River dolphin, and 12% of these were delineated as conservation priority zone. We also presented this recommendation to the Uttar Pradesh Forest Department, which took it up, and the Kachha Wildlife Sanctuary downstream of Prayagraj was declared. To address those species which were caught in nets or were caught during poaching, what would happen to those species? For those species, we established rescue and rehabilitation centers in collaboration with the Forest Department and also in collaboration with Narora Atomic Power Station. 2 of these at Bhagalpur and Barakpur have been handed over back to the Forest Department, while the rest are being jointly operated by our team and the Forest Department. So far, we have rescued about 6,000 individuals of turtles from these rescue centers. But what will happen when the project ends? So to ensure the sustainability of the rescue operation and that the rescued individual get the same veterinary care, we train veterinarians around the areas, and we also train first responders, which are the people from local communities who would get the information and relay the information back to the Forest Department and then effectively help in rescue and rehabilitation of these aquatic species. We also trained forest department personnel to handle rescue operations. As mentioned earlier, there are about 650 million people who reside in the Ganga Basin. How do we engage them in conservation? To engage them in conservation, we applied a multitude of approach. We went to them through padiyatras, we went to individual villages and we spoke to the villages and local community members and tried to find out what their linkages are with the Ganga River. To our surprise, we found that the local communities, they were very well connected to the Ganga River and they also knew about species, though not the scientific name definitely, but they knew about species much better in a way than we were at that time. So we reached to these communities, we ensured collaboration and support through liaison with different partners in conservation. We did stakeholder consultation and carried out need assessment. Based on these need assessment, we provided training to various stakeholders. We built a team of spearhead members, which actually are spearheading conservation initiatives in their respective sites. These are the members who are carrying forward conservation activities in their own state. For example, we have spearhead team members from Forest Department, from Eco Task Force, from veterinarians, from universities and colleges. So far, we have about 1,000 spearhead team members, which were trained through 6 trainings over the period of last 5 years. And similarly, we have trained about 9,000 people through 74 trainings on various aspects of aquatic conservation. As mentioned earlier, involvement of local communities is very crucial for conservation of aquatic species. So here, we first of all, when we had one-to-one talk with the village panchayat members, then we get to sign memorandum of agreement with these village panchayat members, and we also created new platforms for interaction and dialogue. Ganga Prairie Cadre represents one such platform where individuals who are keen to participate in conservation of aquatic species, they are trained at our institute and at their respective sites also. And as of now, we have more than 4,000 people as Ganga Prairie enrolled in our cadre, and more than 50% of them are women. I'm delighted to tell you that some of these Ganga Prairies are now part of our WI research team, either in the Ganga project or in the Kemper Dolphin project. So Wildlife Institute, not only Wildlife Institute of India is giving them employment, but these Ganga Prairies have been linked with other governmental agencies also, where they are engaged part-time or full-time, depending on the capacity that they have built over the years. How do we ensure, or how do we know that these Ganga Prairies are carrying forward activities? So for that, we have measured the input activity, that how much input we have given them in terms of training, and how much activities they are carrying forward in terms of output. And as can be seen through these numbers, these Ganga Prairies are actively working in the basin for conservation activities. These Ganga Prairies have also been recognized at local level, state level, and national level. Here, one of our Ganga Prairie, Shri Darshan Mishra ji, can be seen with the Honorable Prime Minister of India in Banaras. We also aligned the local livelihoods with conservation initiative in Ganga conservation, and we came up with the idea of ecotourism site, which on board for dolphin safari, which we call Jalaj. This model of Jalaj was launched on Dolphin Day in 2020, and later this model has been taken up for the entire Ganga Basin as a separate Jalaj project by NMCG. This Jalaj initiative is also contributing to the Earth Ganga initiative of the Government of India. Not only that, we did a lot of outreach activities all across the basin. These points just highlight some of these activities that we have been doing. We have established 3 interpretation centers, Ganga Avlokan at Haridwar, Anubhuti at Kanpur, and Ganga Darpan at Sarnath, which are providing information on the biodiversity of Ganga and the journey of Ganga from Gomukh to Ganga Sagar. In the same sequence, we have also created Jalmala Samvad, which is a low-cost interpretation center, and Bal Ganga Prahari corners all across the Ganga basin. So far, we have about 48 Jalmala Samvad and 14 Bal Ganga Prahari corners, which are creating awareness among school students. We also carry out a lot of workshops, games, and activities such as web of life, animal stapu, biodiversity dart, and Sudoku, which are all based around aquatic species. Apart from that, we also did pre and post questionnaire survey to know the effectiveness of our trainings. We found that post retention was 20% in case of school students, whereas in terms of for spared team members, the post-training retention was 46%. The scientific information that we gathered through literature review and ecological survey was transformed into outreach material in form of books, brochures, manuals, research papers.
नमस्कार, कार्यक्रम गंगा की बात की 9वीं कड़ी में आप सभी का हार्दिक स्वागत।
2014 में न्यूयॉर्क में मेडिसन स्क्वायर गार्डन में भारतीय समुदाय को संबोधित करते हुए प्रधानमंत्री श्री नरेंद्र मोदी ने कहा था, अगर हम इसे साफ करने में सक्षम हो गए तो देश की 40% आबादी के लिए एक बड़ी मदद।
So, as you heard, we are also reaching out to the masses through TV and radio channels. And this is our journey. So in 2016, we started with only 79, we could reach out to only 79 stakeholders. And this is September of 2023, and we have reached out to about 250,000 stakeholders, and we will be reaching out to many more. We have created social and economical mobility of women and poor. We have strengthened linkages between the community and the governance. We mapped status of species of conservation significance, and we found that 40% of the basin has high biodiversity value, and only 12% of the river stretches are protected as protected area. So we need to strengthen up this protection measure. And one of our work was upscaled as was taken up by National River Conservation Directorate. My colleague Dr. Tanveer Ahmed will be talking about it. This tall work would not have been possible without the support of following people. And I leave you all with this clipping from the field. Thank you.
Thank you, Dr. Shivani. Now we'll move to the next presentation. I invite Marie Jacob. She will be presenting a sound solution, just to reduce the mortality of river dolphin. Over to Chidambaram.
Marie Jacob is currently working in Kappa Dolphin project as project fellow. She has worked extensively on the ecology and acoustic behavior of gangster dolphins in the major habitat of them in India.
Good morning all. Thank you for an introduction, Chinmaya. So today in the morning section, my colleagues are already introduced two major threats to Ganges river dolphin. One was the poaching, the other one was the changes in the underwater landscape. So I am also introducing a threat that is the net entanglement of the Ganges river dolphin. Along with it, I am bringing a mitigation solution to prevent Ganges river dolphin net entanglement. I like to introduce you to my topic, a sound solution fingers to reduce river dolphin mortality. Myself, Marie Jacob, and I am working under Professor Kamar Qureshi and Dr. Vishnupriya Kullipakam. Already species being described, but I want your focus on two aspects of the species. One is they are almost blind as an adaptation to the murky waters of the rivers, which lead them to depend on echolocation. What it means? So echolocation becomes the primary sense. They use this echolocation for foraging, navigation, communication, or any other activity. But the thing is, this highly evolved echolocation is actually inept in detecting the monofilamentous fishing net, which lead to the net entanglement and also which is the leading cause of dolphins' direct mortality. So I will be explaining now. We can have a group over here. So what is happening here? So when the monofilamentous gill nets or any net get submerged into water, it will become very thin. So the density of the net is as similar to that of the water. Hence, the dolphins cannot detect this monofilamentous nets, and this lead to the net entanglement. After they get entangled in the net, because it's been a mammal, it need to surface for breathing, and it not able to come up for breathing will lead it to drowning. So this is the recorded cases of dolphin mortality from both Brahmaputra and Hooghly River. Of the 18 cases of dolphin mortality, 61% was due to net entanglement, whereas in Hooghly, the 41 mortality of this 46% was due to net entanglement. As you can see in this map, the current scenario of net distribution in India, it is widespread, so it is very much prevalent in both Ganga and Brahmaputra, with 2 nets per kilometer for Brahmaputra and 1 net per kilometer for Ganga, whereas in case of Hooghly, it's 4 net per kilometer. There are a lot of nets. So it's actually not only an issue in the freshwater ecosystem. The bycatch of cetaceans is happening there in the marine environment also. So throughout the world, people were trying to try various mitigatory measures, and some of them we acoustically reflect in it, where you put like iron sheets or things into the net to make it more acoustically active, using visible detectable net, which is like you will be putting light emitting iron. Leave it. And also the other thing is like otherwise you will make the nets really colorful so that the dolphin can see them. And another solution is sound producing devices or acoustic deterrent. In our scenario, our dolphins fully depend upon echolocation. So because they depend upon the echolocation, no solutions where the visual cue can be used cannot be used. So we decided to check the efficacy of an acoustic deterrent, and over here the acoustic deterrent which we choose for testing the efficacy was fingers. So to conduct this experiment, we need to then find a study site where we can try our experiment. The field should also have a good dolphin population so that we can generalize the data. Then fishing activity, because we need to test it with the fisherman to know how it is affecting the fisherman and the fish catch. Also, there should be sufficient depth for our acoustic monitoring devices. All these points together lead to us to choose Guwahati in Brahmaputra River as our study site. Now I will introduce you to our equipments. First, as I said, we need an acoustic deterrent to conduct the experiment. We choose pingers. Pingers actually emit the sonic pings, that is 14 pings per minute at a frequency of 17 kilohertz. The 17 kilohertz is actually the model frequency used by the dolphins. This is then followed by an acoustic monitoring instrument. Here we use seaports, which will actually record all the clicks emitted by the dolphin. Then we have a visual team who will just sit down and observe the dolphin. It consists of 2 members, 1 observer, 1 recorder. And for all the data collected from this one, we analyzed it using R, and also the data from the seaports were exported using seaport.xs. We carried out various tests like ANOVA, TUKI, PT tests, chi-square, KS, and all other tests. So now looking at our experimental setup, this is our overall experimental setup for both the visual and also for the acoustic. Our experimental setup consists of 3 seaports. The central seaport being your treatment phase, and the other 2 will act as your control, and we will introduce fingers into these seaports with the fishing nets. There also was 3 phases: pre-treatment phase of 6 days, treatment phase of 18 days, and post-treatment phase of 12 days. And our visual team, I am elaborating the setups. Pre-treatment phase is the phase where fingers were inactive, or you can say this is the virgin phase where there was no disturbance by the finger noise. This was followed by a treatment phase where the fingers were active and they are emitting the sonic pings. This is then followed by the post-treatment phase where again fingers become inactive. I think you got the pieces. Then we look into the effective detection range of the fingers. Because we are going to use the fingers, we need to know if they are pinging properly, and if the sound is degrading and how fast the sound is degrading in the water. So we calculate, and also to understand how many numbers of pingers do we need if we are going to use the pingers. So we conducted the experiment both in the upward and downward flow of the river, and we deployed our pods. Then every 50-meter interval for 500 meter, we deployed the pingers and recorded the sonic pings in the seaports. And then we calculated the average sonic pings. So we were able to see that there was more than 90% sonic ping detection in case of within 150 meters, and whereas the sonic ping after 150 degraded drastically, and by 400 meter entirely the sonic ping missed from the seaports. So we were able to find out that the effective range of pingers is within 400 meters, and the sound is degrading after that, and the most effective range is within 150, and we decided to keep one pinger per every 100 meters of the net. So now come to our major questions. First was, are the pingers really able to deter the river dolphins from the fishing nets? For carrying out this, we were having two setups. First was our control period, where there was no active pingers, and we recorded the dolphin activity. Over here, we were able to see that we are getting at least 23 dolphin positive minutes per hour, and after this, we are introduced our treatment period where the pingers were active, and over here we only got 2 dolphin positive minutes per hour, which is actually indicating there is actually acoustic decline in their activity, but both their activity peak and pattern remain same, which is actually indicating there was around 90% decline in the acoustic activity of Ganges river dolphins. And yes, pingers are efficient in deterring dolphins from the fishing nets. This was lead to our second question. If we are using the pingers continuously, then if the habitat getting avoided by the dolphins. For this one, it was the important question, because we need to know if by using if the habitat is getting excluded by the species because they are losing a suitable habitat. So carrying out this, we done 2 experimental setups. One is pre-treatment phase to understand the natural acoustic activity of the dolphin, followed by the post-treatment phase, which is to understand the dolphin acoustic activity after the removal of pingers. In both the phases, the pingers were inactive. So we got the results. In the pre-treatment phase, we got around 21 dolphin positive minutes, and whereas in the post-treatment phase, we got around 28 dolphin positive minutes. We compare both the phases to see if there was any significant difference with the phases, but there was no difference. So we were able to say there was no habitat avoidance or exclusion by the dolphins. Moving to our next question, which was to understand how far away is dolphins is surfacing from the net. For doing this one, what we done was there is a visual observer team which was always looking at the net, and they were recording dolphin surfacing at how many meters away from the net, what type of which age class they were, and all other activities. For this one, we recorded 112 hours of data. There was 4,800 dolphins surfacing. Of this, 3,000 was non-calves and 600 was calves. So this was our overall result, both of the adult and calf. And from our result, we were able to determine 30 meters as the zone of exclusion, because there was 50% reduction in the overall detection of the dolphins. But there was an interesting finding over here. The reduction was only 9% in case of calves. It may be because the directionality and the full development of acoustic activity in the calves is actually happening after 6 months of their growth. So we move to the next question, that is to understand by the introduction of the pingers into the river ecosystem, if it is actually affecting the vocalization of the dolphins. For this one, we were having 3 phases: pre-treatment phase without pingers, treatment phase with pingers, and post-treatment phase again without the pingers. During this one, we looked into two parameters, acoustic parameter. First was the model kilohertz, which is the most used frequency by the dolphins. And we was able to see that the model frequency used by the dolphins in the post-treatment, pre-treatment and treatment period was between 70 to 19 kilohertz. Over here, I want you to have an attention, please. So there is two peaks in the frequency. There by model, one is towards the 18 to 19, the other one is between 17 to 75 kilohertz. Okay, so when the one amazing finding we got during this one was, the finger frequency was 17 kilohertz. We were able to see that dolphins is actually avoiding the finger frequency, that is 17 kilohertz, and during the treatment period, they shifted the frequency below 17 and went to between 60 to 70 with a model frequency of 65 kilohertz, which is actually indicating masking by the dolphin. But after the removal of the fingers, it again went back to normal and all the frequency was same. Then we looked into the sound pressure level, which is actually the loudness of the sound, and there was no difference among any spaces, which indicating that they are not clicking louder in presence of fingers. Then the last question, that is to know how effective is fingers in case of fish catch. We take out the results from fingered nets and also from the non-fingered net, and we were able to see there was no difference between the average CPU in the fingered and non-fingered nets. So coming to the conclusion, we were able to see by introducing fingers into the waters, we are able to deter the dolphins from the fishing net. By far, fingers are the most promising and effective bycatch mitigation device for the Ganges River dolphins. There is 90% decline in their activity, and the zone of exclusion, that is within 13 meters, the surfacing has reduced by 50%, and also there is no effect on the fish catch of the study area. But some implication from over here was like, even though the fingers were able to deter the dolphin, the effect on the calves are very small. So we need to have other measures also to prevent dolphins net entanglement. That is combination of both acoustic along with other mitigatory measures like banning the monofilamentous nets or buybacking schemes for the monofilamentous net. We can introduce reduced strength nets and other mitigatory measures. Also, rescue and rehabilitation capacity for entangled dolphin need to be developed. Most of the scenario, even though dolphin get rescued from the net, they will die because of the stress of handling. Then we also need to carry out social surveys to know about the acceptance of fingers by the fisher folk, as they are the one who is actually going to use this in the field. With all this, I like to acknowledge all my team members, specifically Aranya, Sunny, Hia, Tabasum, Anurag, Ranjana, Dr. Abdul Waqid, Jury and Shalom, with whom it was impossible to conduct this experiment. And the amazing illustrations of this was made by Swasti. I like to acknowledge her also. And all my other team members, field staffs and board staffs of Assam. And with all this, I like to say thank you. And this paper is available.
Thank you, Malin. So next, I invite Dr. Tanveer. Dr. Tanveer, he will be presenting on an insight into ecological status of selected Indian rivers. Over to China.
Dr. Sangai is a master's, MPhil and PhD in wildlife sciences from Aligarh Muslim University. He is currently working as a project coordinator in the project of assessment of ecological status of selected Indian rivers for conservation planning. Over to you, Dr. Sangai.
Thank you for the introduction. Good afternoon, everybody. What you see on the screen is a calm and a soothing image of river. River are considered as lifeline for humans. In many of the Asian civilizations, including Harappa and Mohenjo-daro, have evolved along the course of river. Even today, many metropolitan cities are thriving well along the course of the river. In India, rivers are considered sacred. They are regarded as goddess. They are worshipped as goddess. They are regarded as mother. For instance, Ma Gange, Kaveri Amma. Humans are dependent on rivers to secure their livelihood through tourism, through agriculture activities and fishing. Rivers provide most important natural resource to the humans, that is water. Yet rivers are in crisis. In India, rivers are in a very pretty condition. Due to the excessive extraction of the water from the rivers, many rivers are water stressed. If you look at the water per capita availability in the rivers, it is as low as 263 cubic meter, and in many renowned rivers like Krishna, Kaveri, Pennar, Mahi, it is less than 1000 cubic meter. Moreover, the natural flow of the river has been disrupted and the pollution carrying capacity has been declined due to construction of large number of dams. There are more than 5,000 dams located on Indian rivers and many are underway. In addition, pollution has been added directly or indirectly to the rivers, and it is important to note that only 37% of the municipal waste that is generated from class 1 and class 2 cities has been discharged into the river. The industrial effluents containing heavy metal, pesticides, pharmaceuticals affect the riverine fauna directly or indirectly through bioaccumulation and biomagnification. The team of Boris Marty suggested that Indian riverine fauna are highly threatened. Therefore, it is utmost important to conserve the riverine fauna in India, and it could be achieved through scientific solution along with giving regular protection to those species and pupil participation. Today, I will be giving presentation what we have done in last 1 and 2 years in the project assessing the ecological status of select Indian rivers, and I will be presenting what we have found in Barak, Godavari and Periyar and what other things we have done in the project. Just a quick glimpse of the rivers. The first river we have studied is Barak River, which is located in the northeastern part of India. It originates from the Liai-Kuling village of Manipur and merged with Bay of Bengal, passing through India and Bangladesh. It is a 900 kilometer river, of which 564 kilometer lies in India. Godavari is the second longest river in India. It passes through Maharashtra, Telangana and Andhra Pradesh. And Periyar, it originates in Kerala and end up in Arabian Sea, flowing through the Kerala. Godavari has the largest basin among the 3 rivers. It passes through 8 Indian states and 55 districts. And among the 3 rivers, Periyar has the smallest basic area. Godavari basin is largely dominated with agriculture, whereas Barak and Periyar basin is dominated with forest area. If you look at the forest cover along the course of the river, we found that more than 40,000 square kilometer of the forest area occur along the course of Godavari river, 18,000 in Barak river, and around 4,500 along the course of Periyar river. Similar situation exists in the human population, where in Barak, 50,000 people live along the course of Barak river, more than 5 lakhs live along the Godavari river, and more than 43,000 along the course of Periyar river. So the major task was to do a preliminary assessment of the river. So for that, we have surveyed the entire stretch. We have not surveyed the entire stretch of the river, but we have delineated sampling stretches. So in each stretches, we have laid 3 transects. On each transect, we have assessed the birds using mechanism species richness method, reptiles and amphibian using visual encounter method, and this mammals through recording of direct and indirect evidence of aquatic mammals. This is just a glimpse how we have collected data from each river. So we found that around 32% of the plants found in the Barak basin occur in the occur in the Barak River. 73% of the plants found in the Godavari Basin occur in the Godavari River, and 88% of the plants of the Periyar Basin occur in the Periyar River. We also recorded threatened species of plants which were higher in the Periyar River. As far as fish are concerned, we found that higher richness of fishes in Godavari River, which is 47% of which is found in the Godavari Basin. And the concentration of the threatened species are also high in the Godavari River. As far as Herpetofauna is concerned, almost equal number of reptiles and amphibians found in the Periyar River, and in Barak, very low number of amphibians and reptiles were found. And the concentration of threatened species were also high in Periyar River. Our major focus on the birds was to get the information on the aquatic species. However, we usually cite terrestrial species, so we recorded both the species, but we found that the richness of water birds was high in Godavari River, and threatened species were threatened and near threatened species were higher in the Periyar River. The literature suggests that one species of water found in Barak River escape, one in Godavari, and 3 in Periyar River escape. Of that, we were able to locate 1 in Barak, none in Godavari, and 2 in Periyar River escape. So, to meet the second objective, that is the delineation of protected areas, we downloaded raster layers such as elevation, slope, land use, land cover, annual average precipitation, soil from various online sources. And we also collected water temperature, flow, TDS, pH, DO, river weight data from the river, and these were interpolated using ordinary rigging to develop raster layers. All these layers were used to develop various habitat suitability models using MapSend. Around 43 habitat suitability models were developed for fishes, 33 for Herpetofauna, 98 models for birds, 8 terrestrial species, and 1 aquatic mammal species. All these habitat suitability models developed for the various taxa were merged together to find out the ecological or the biodiversity hotspot. We found that in Barak, around 42 kilometers of a stretch is the ecological hotspot, 22 kilometers in the upper zone, and 20 kilometers in the middle zone. This should be bring under the purview of Indian Wildlife Protection Act for the conservation of riverine biodiversity, as there is no protected area on the river. Besides that, we have also tried to involve local people for the conservation of river through celebration of various utsav and festivals like Nadi Utsav, in which we have spread awareness about the rivers and its conservation to more than lakhs of individuals. We have also celebrated International Day of Action of River. We conducted a Har Ghar Tiranga program in every river basin, and we also participated in Vibrant Northeast. We developed brochures for every rivers and for various taxa for distribution and sensitization of the stakeholders. So this is just a preliminary assessment of 3 Indian rivers. There is a lot to achieve in future. In future, we will be doing survey in Narmada, Mahanadi, Godavari. We will also try to find out factor influencing richness of species in each river. We will delineate conservation priority zones in all 6 rivers, assess the genetic diversity and gene flow of aquatic species, and prepare site-specific conservation plan. Before I end up, I think I am on time and before time. So before I end up, I want to show how our team has done survey in Godavari River Escape, because prior to this, I always think it's very simple to go and sit in the boat and do the survey. But our team has done a good job. I want to show this.
జీవన ధారవు నీవై పరుగులెత్తిరావా, ధరణికి పచ్చని పులకాంకురముల వరములీయరావా, పుష్కర వేళను పుష్పాంజలితో అందుకొనగసేవా, పుష్కల జలముల పుడమిని తడిపి పంట సిరుల నీవా, ఉరుకుల పరుగుల ఉరవడుల కరగల నురగల గలగలల సరిగమ పదని స్వరజతుల తగధిమి తగజణుల యగతుల అభంగ తరంగ మృదంగ తురంగ దక్షిణ భారత గంగా.
So, similar situation exists in every river. So, I would like to acknowledge these many people and most importantly, my team members who have conducted survey in this condition. Thank you.
Thank you for taking the time also. So next, I invite Mr. Mogi Mundriya. So we will be presenting as to where the solitary nesting olive will go. Tracking the migratory journeys of turtles from the Maharashtra coast.
The outlaws says a lot about. It is a former MSc student from Wildlife Institute of India. Since then, he was inclined to work on marine turtles, and currently he is working on the pan-Indian population of olive-footed turtles. Over to you, all the best.
Hope I am audible. Am I? So good afternoon everyone. I am Mohit and today I will be talking about a species that this stage of ARS have been witnessing a lot of stories in the past. The people who know the WI history must be knowing this. So this is the olive sea turtles. Now olive sea turtles are the smallest and the most numerous sea turtle species that you find in the tropical waters around the globe. Many of you might be knowing this species because they do some very interesting nesting, which is called Herpetofauna. So in an Herpetofauna, you can see hundreds and thousands of turtles coming together and nesting in a very small stretch of beach within 3 to 10 days. And after witnessing one of those events, I can say it is one of the greatest events I have ever seen for the animal world. These Herpetofauna events are not seen everywhere, and there are only few places in the world you can see them. One of them is, so some beaches are there, there are select beaches which are there in the center of America and then on the east coast of India. So along the Odisha coast, there are 3 river mouths where large Herpetofauna are known, but the whole 7,500 kilometers of Indian coastline is a potential olive nesting habitat. But these turtles don't do Herpetofauna there. They come alone and they nest solitarily. Because of the given importance to the, because of the conservation importance of these turtles, because of the conservation importance, a lot of studies and great details of the ecology of Herpetofauna nesting turtles have been studied, and many institutions, including WIS, have had a lot of studies in the last 30 years. But what about the solitary nesting turtles? So, one of the greatest tagging effort, flipper tagging and satellite tracking effort from these Herpetofauna nesting turtles found these turtles to migrate all the way down to the southern Bay of Bengal near the Sri Lankan waters and also using the open waters. So these turtles are migratory and they have distinct foraging and nesting grounds. But what about the olive turtles that nest solitarily all along the Indian coast, including the Lakshadweep and the Andaman Islands? Unfortunately, we have very few studies talking about the ecology of these nesters. So this is one of the solitary nesting turtles. So even more so, when you go to the west coast, you don't have any information on their ecology. the information we get are mainly from the status surveys and old reports, anecdotal reports about sea turtles. And what about the turtles? Where do they go? We don't know. Along the Maharashtra coast, we have Mangrove Foundation, which has been actively conserving these turtles by creating awareness, by maintaining sea turtle hatcheries, and then also providing compensation to fishermen who are damaging their nets for release of the turtles. And they wanted to get more information on what these turtles are doing, and they funded this study with the objective of understanding the nearshore and migratory movements of olive turtles that nest in Maharashtra. So for this, we undertook satellite tagging of 7 sea turtles from 3 nesting areas of Ratnagiri district in Maharashtra. For the first time in India, we deployed satellite tags which had dye sensors, which gave us information on the tagging behavior of the sea turtles. So the Argos locations that we get from these tags have associated error, and to correct for it and to model a correct path, we use state space modeling, and then in the nearshore areas when these turtles are in breeding season, we wanted to know if they actually stay there or they do move out, and if they do stay in those places, which are the most important areas, because these turtles are very vulnerable when they are in the breeding phase. So we use turtle density estimation to find out their core use areas, and then from the model, and then we wanted to know what movement behavior these turtles are having. So we use movement persistence model, which gives us movement persistence index. So for any day, if the movement persistence index is high, that means the turtle was doing a directed movement, and it shows migration. But if the value is low, it shows that the turtle is moving slowly, changing its direction multiple times. So this mostly shows residency or stopover size, or sometimes even forgetting. And then we had the dive sensors. So we got to know how deep these turtles are diving, what dive length these turtles are having, and what kind of shape these turtles have. So there are mainly 2 types of dives, as depicted here, a U-shaped dive and a V-shaped dive. So when a turtle is doing U-shaped dive, it is usually considered resting because it goes down and stays at the deeper depth. But for a V-shaped dive, a turtle is going down and coming up, and it is mostly associated with exploratory behavior or foraging. So with great efforts, we caught 7 turtles, tagged them in Maharashtra, released them, and we were curious to know what these turtles will do. What we found was that these turtles, we could track these turtles for 121 to 173 days in last year, and then the turtles that we tagged in February this year, they are right now active, and as of today morning, they have given us 121 days of information. These turtles, not all, so these turtles stayed in the nearshore areas after we released them, and then we saw what are their movement patterns in the nearshore areas. So these graphs show you that the turtles actually remain very close to their foraging areas, when they are in the nearshore waters. And the size of their foraging areas also vary. Very interestingly, we had 2 turtles that were actually coming, and they were actually observed to come and renest. So we had the Prathama and Savni, which we tagged in January last year. They came, they renested, and with the diving data and their behavior, we were able to tell.
Mohit, keep your mic close.
We were able to tell. It is stopping, so I just.
Or use that mic.
Then you go to this.
Okay. So we were able to tell that these turtles actually came back nesting, and then and 15 days before they nested, they started moving very close to the shore. Then when we combined all the core use areas of the turtles, we found that a clear association was there with the river mouths, where these turtles were staying in waters less than 30 meters depth, and they were doing long U-shaped dives, which means they most probably were resting in those areas, which is also known for loggerhead turtles from other places, and even olive turtles from Odisha. But then came the interesting part. The turtles started moving away from their nesting beaches, and we wanted to know where they went. So the turtles that we tagged last year, they started moving away. Two moved north, while two moved south. And after a point, by May, all these turtles started moving south. These turtles stayed in the Arabian Sea, associated with the continental shelf. But unfortunately, our tags did not work well, and we were able to track them for a small duration of time. So we got new tags this year, and we tagged two more turtles, and then they started moving. One turtle did a very similar movement to what the turtles did last year, but very interestingly, one turtle went all the way south to Sri Lanka and then went to the southern Bay of Bengal, which we didn't know that these turtles can do. We looked at how their movement behavior changed, and the graph shown here is basically telling how their movement persistence changed during the tracking duration. And what you can see is that in the starting phase, in the starting phase, you have very low movement persistence because they were in the breeding season. And then you see spurts of high movement and then followed by slow movements. While in case of Bhageshri, as soon as we released her, she started her migration. She did not stop until she reached the Sri Lankan waters. Based on the movement persistence, we found where these turtles were actually stopping. And very interestingly, the areas of Karwar coast in Karnataka was where all these turtles were coming together. Other places, for example, these places were separated spatio-temporally, and Bhageshri, for sure, she was a long-distance migrant who just only stopped when she reached her foraging ground in Sri Lanka. We looked at how the diving behavior changed for these turtles. So we saw in the foraging areas or stopover sites, these turtles were doing more V-shaped dives, which is associated with foraging. Also, these places were deeper, so these turtles were doing deep dives, and the deepest our turtles went was 459 meters, and they were doing significantly shorter dives. But in this great expanse of ocean, what decides where these turtles go? Unlike us, the turtle knew where they wanted to go. But what was deciding their movement patterns? So one interesting thing some of you might know that these current systems are present in our oceans, and there is a special West Indian coastal current which these turtles might be using to migrate south. Very likely, even Bhageshri used the same currents to go till Sri Lanka. What about the turtles that move north? So these currents have reversal from November and they flow northwards up to February, and these turtles might be riding those same currents to go north, and when the reversal happened again, these turtles started moving south. But then why didn't all the turtles go to Sri Lanka? Why did they stop off the Karwar coast? A very important reason could be this upwelling zones. The green color shaded areas are upwelling zones with high productivity, and especially on the west coast, we have Malabar upwelling zone during the monsoons where the productivity increases, and even the fish catch in those areas increases by multiple folds. So these turtles for sure knows that where the food is available, and they might be moving to the same areas. What we are interested to know now is what the turtles that we are having currently active will be doing in November, when the whole current system will move back, when the upwelling zone is over. Where will these turtles go? So we hope to track them more, and with this I will I forgot to tell you that the other studies from Sri Lanka, Odisha, and from Oman, they also show that the turtles actually use these upwelling zones, and you see high overlap, or you see not high overlap, but you see overlap between the foraging areas of turtles nesting in different places. And it is known for different species of turtles, so they do come from different nesting area and they mingle with each other. Right now, Guha, which was tagged in our study, who is in Karnataka, she might be using the common foraging data with the turtles we tagged last year. While Bhageshri is mingling with the turtles that is coming all the way from Aribada nesting populations. Just from the 7 turtles that we tagged in this study, we found that the Maharashtra population at least have 2 different kind of movement strategies. These turtles, one of them stay faithful to Arabian Sea, while the other turtles moving all the way to the Bay of Bengal. The turtles in the nearshore waters, in the breeding season, use nearshore waters around the river mouth, and these are the priority areas which we need to conserve for protecting the turtles. The upwelling zone and the oceanic currents seems to have a effect on how these turtles move, but then I need to analyze this data more and see if these are actually statistically prove that if these turtles are actually using these whole things. And then I think that more effort of such tracking the turtles should be taken from solitary nesting areas all along the Indian coast, because their nesting might not be as impressive as Aribada, but their stories are. With this, I would like to acknowledge all the people mentioned here, especially Virendra Tiwari sir, who was very instrumental because he was the executive director of Mangrove Foundation when we got this project. Dr. Shivakumar sir, who was an important part for initiating the study, and Dr. Manas Manjrekar, without whom this study would not have been possible. With that, I would like to thank all the Forest Department people, Mangrove Foundation staff, and all the volunteers and interns who spent sleepless nights looking for the turtles. Thank you.
Thank you, Mohi. So now we can take the stage. I also request other presenters to come onto the stage to take the questions. Now I request Timia to facilitate the question and answer session.
Actually, we got so many questions, but we have a less time. So what we do, we will restrict the questions to only 2 questions per presenter. The remaining questions you read out the persons who actually ask the question, so that the concerned presenter can go and meet that person and clarify that.
Yeah, the first question is for Shobhani. We have a question from the SSS Chair. He is asking, please comment on the threat of plastic settling over the marine grasslands.
Yes, sir, thank you for bringing that up. We have had a limited number of sample sizes where stranded dugongs were also studied for the dietary analysis, and we have found microplastics in the gut content of dugongs. So, in our threat mapping, we definitely have looked after the marine leader aspect as well, but primarily I just only presented the threats in terms of boats, but we do have the data for marine leader as well. So in that sense, but because this was just a one-time study, we cannot draw conclusions on the intensity of marine litter, because we all know that the litter is brought to the coastal areas because of many reasons. The ocean current patterns, every day the tidal fluctuations are so much. So if our study overlaps with high tides, the high tide is going to bring a lot of litter inside. So we need to have seasonal replicates to come with a robust information on that, which is why we did not present it today.
The second question is from Sudhi. Which component, great work in presentation, he says, which component of the citizen science program contributed the most in Dugong counter information?
Which component, as in you mean stakeholder?
Which component of citizen science program contributed? So I think it might be.
Alright, so our primary stakeholders were fishermen across the 3 sites. They were consistently giving us the sightings. So fishermen definitely, and it was very much site specific. So in Gujarat, the primary informants were fishermen. In Tamil Nadu, it was fishermen along with marine police. Andaman mein, because it's a very diverse place, the availability of stakeholders is very high as compared to other areas. So if you also see the number of sightings which we have received from Andaman are high, because we have 7 very active stakeholders, Indian Navy, Indian Coast Guard, and scuba divers are the stakeholders which are not there in the other sites. So site specific variation was definitely there, but the most common the fishermen.
And is there a chance of misidentification of dugong by the fishermen?
Very nice question. So, not always do we get pictures, photographic documentation, so your question is very valid. So, to at least address this bias, if not remove it completely, what we do is, the first step of creating a citizen science program is massive sensitization. So, stakeholder specific sensitization programs, when we do brief about how to identify a dugong. That is the first thing which we do. So if it is defense bodies, we tell them how a dugong looks like from air. If it is boat-based patrolling agencies, how it looks from the boat and something like that. And for fishermen, we cannot always ask for photographic documentation because they don't carry smartphones, they carry the basic phones, and we give them the benefit of the doubt because for so many different aspects, fishermen know more than us. Even after we having degrees in marine, we cannot beat that knowledge. So we do trust that.
There are more questions for you, but we cannot have them right now. You can discuss with the question, the aspect later. Thank you. I will invite Dr. Shivani to answer the question. The first question is by Dr. Lalit. He comments your presentation, very informative presentation. What are your views on invasive species infestation in Ganga?
Yeah, very good question. Actually, we have our team which is working on fishes. They have found invasive fish species all across the Ganga basin, and particularly in the upper Ganga basin, where snow trout is being replaced, and also in the middle Ganga, where invasive species are present. They do pose challenge and danger to the native species, particularly when the climate is changing and temperatures of the waters are changing.
In continuation to that, he asked, invasive fish are major issues in Ganga and should have been considered when we are making the planting races.
Yeah, that is a good observation. Actually, this entire project is a very big project, and 15 minutes of time was not enough to present all the components. In fact, I've missed out also on Herpetofauna and the vegetation component. And my apologies for all of those who have been working on those components. I could not concise all that information in 15 minutes time.
The second question is from Dehradun, commendable effort. One aspect of the project is to measure improvements of ecological conditions of the river from the findings of the project. Are there any improvements in the ecological conditions since the initiation of the project?
Yeah, so this project was initiated in 2016 in mainstem of the Ganga River. And when we compare dolphin distribution in mainstem of the Ganga River from 2016 till now, we say that the distribution has spread out, the dolphin has spread out, which shows that the ecological condition has improved in a measurable way.
That's all for you, Dr.
Thank you.
Thank you. Many. There are a lot of questions for you, so I guess you have to take time at lunch to talk to people. The first question is from Dr. Shivbala. What are the effect of fingers on other species? Is there any similar study done in other countries regarding the finger use?
Okay, thanks for the question. So firstly, fingers, the frequency which is actually emitted by fingers is actually 17 kilohertz, which is actually the frequency used by most of the cetaceans. And there are a lot of works done on marine ecosystems regarding the use of fingers acoustic deterrent. And there are studies which is actually also had habituation by the dolphins. So yes, there are a lot of studies based on fingers in in marine ecosystem.
The second question is from Dr. Bilal. Excellent presentation. Considering number of nights across Indian rivers, 2 to 4 per kilometer, do you think width of the rivers may have an impact on the dolphins in the habitat avoidance? In the perimeter habitat avoidance. Did you understand the question?
Okay, I think what you are trying to ask me is that the river is really wide also, and They can avoid. I didn't get the question. Be fine.
Sorry for the writing. So my question is, when you have a smaller river versus a broader river, so in case of a smaller river, you have a space to go, so the avoidance will be less. But in case of smaller rivers, you don't have a space to go. So if you go down the river, there is a one more net. Okay, then probably a availability of habitat will decrease with the width of the river.
If you remember yesterday when Vishnu ma'am was presenting, she brought in this one and even shown an image where the dolphin will get restricted. So with the width, it's actually depending upon the river, and nets which is currently being used in Ganga or Brahmaputra, it's not throughout the length of the river most of the time. Some places they do the corralling process. So I think I don't know. Yeah, it is possible. Like dolphin will avoid it or otherwise. I don't know how it is mitigation for fingers. Yeah.
Thank you, ma'am. If I answer the questions later.
Okay.
Dr. Tanvi. The first question is from Dehradun. Nice presentation and excellent teamwork. Earlier, Dr. Balwal emphasized the river connectivity is essential for health of rivers. However, the river interlinking projects are going to improve or affect the health of river ecosystems, the biodiversity. Your comments.
See, Dehradun. See, there is no such study yet assessing what will happen after interlink. So as of now, we are in a position to collect the baseline information of every river. So what will happen after interlinking, whether it will affect positively or negatively, we cannot comment. That will you have to assess. Then only you can say what will happen if we interlink the river.
The next question is from Kumar Aunty. Nice presentation. What is the parameter to designate a particular stretch as biodiversity hotspot? Is it species richness or species diversity or both?
No, we have not designated ecological hotspot on the basis of richness or both. Ankit, yeah. We have developed each species habitat suitability models. So these suitability basically we have taken the niche parameters. So each species suitability is there. So when you compile each species suitability, suppose we have developed some 100 suitabilities. So when you merge 100 suitabilities, all those areas having suppose 90 species suitability. So that could be regarded as the ecological or the biodiversity hotspot. Thank you.
You have one more question which you can answer later. Mohit. You also have so many questions, so please take your time. First question is by Subrata. Does the turtle movement get affected by coastal lines?
Thank you for the question. And so turtle movement in the sense, is it when they're in nearshore waters, when they're nesting or when they're migrating? The question have to be in three different ways. Yes, when they're coming to the shore, they might be getting affected by the lights, but when they are far in the ocean, these turtles, for example, in the nearshore areas, our turtles stayed on an average some 10 kilometers from the shore. So we don't have proof that 10 kilometers away will these turtles have any effect on the coastal lines.
The next question is from Dr. Bilal. Is there excellent presentation? Is there any information about solitary nesting turtles flying Haribada during some stage of their life?
Yeah, so thank you for the question, sir. So when WI was conducting the studies from 1990s, Bivas sir was tagging the turtles. So he actually documented that turtles that were nesting solitarily in Rushikulya actually went in the same year and joined Haribada nesting turtles. And similarly, Haribada nesting turtles also were observed to do solitary nesting in some different years.
You can take other questions from me.
So, appreciate all the presenters for nicely handling the question and answer session. So now I invite my co-chair, Dr. Shivakumar, to add his remark.
Thank you very much, Dr. Johnson. And I quickly like to mention something that the power of the data, good field work actually resulted a good outcome. There are three major programs we discussed on the aquatic section. I remember that inaugural address by the chief guest mentioning about the importance of harmonizing the development and basically mainstreaming the biodiversity conservation in the development sector. And aquatic systems most vulnerable, as actually reiterated by the Dr. Vishnu at the inaugural presentation also, that's supported by another presentation that Dr. Kovici. The blue economy, I don't know how many of you are aware of that. The blue economy, India want to play a role. Right now, India gets about 2.2% of the GDP comes from the blue economy. Blue economy means the economy from the aquatic system. But now government want to increase their 2.2 into 5% by 2030. Then imagine the amount of pressure will be on the aquatic ecosystem. As my colleague Shivani as well as Aravind was talking about the river system. Right now, none of the river in India are undisturbed, actually, unfortunately. And if you want to increase the blue economy from 2.2 to the 5% GDP, means a river will be suffering more in future. Whether it's interlinking project or more hydro project, and that situation, how to save the dolphin in Ganges and Brahmaputra will be a challenging task in the future. And not only that, by 2050, government of India wants to encourage the GDP that 15% from the blue economy. So marine system is going to be affected. The reason is the entire world looking the future livelihood from the aquatic ecosystem because we drained out the resources in the land. Now we are moving towards aquatic body, especially the marine ecosystem. Very wonderful presentation from the Dugong team. Personally, I was very happy to know the outcome. Of course, one of the outcomes is sitting next to me. That's Sangai also as an outcome of the project. And then when I talk about the Dugong, we realized that India has to initiate a dialogue with the Sri Lanka to conserve the population is very important. I hope the director WA will take some initiatives and through ministry to approach them. Otherwise, very difficult to save our dugongs in India because the population goes there coming back as proved by Mobile. Very interesting. Now we have three populations of sea turtles in India. One is on the east coast, one is on the west coast, one is on the Sri Lankan coast. So interesting, all three populations meets in the Sri Lankan water. Many may be knowing that below the Kanyakumari is called a veg bank, the most fertile seashore of the world actually. Probably that attracts all the sea turtles comes to that place according to the upwelling water. It was described before. So then the veg bank is unprotected. Nobody takes care of that region. But it's very critical for the sea turtle to survive long term in the Indian Ocean. So again, I request the director WA to take some initiative to do something so that that particular portion of the sea is taken care of by the Sri Lanka and India as well as small kids. It's an excellent presentation. I really enjoyed it. I congratulate all the presenters. Thank you very much.
Thank you, Dr. Krishna. So we'll note down all your constructive remarks. Maybe in due course of time, we'll take it forward. So now, next, I will invite our chair, Sri Raslisa, to say a few words about this session.
Am I audible? Thank you. Thank you. Thank you, my co-chair, Johnson and Chinmaya, for giving me this, and I thank the director for giving me this opportunity. I was counting the number of years it took me to migrate from that side to this side because in 1991 I was sitting among you. It took me around 32 years to step onto this stage. And so regarding the presentations, if you have detailed the report of the presentation, however, so I'm not going to deal much with that, but I would say that the presentations were not up to the mark. They were way beyond. I was thinking myself, if I were to be asked to give this kind of presentation, I would make the best of it. I am pretty sure that. And all of you guys were excellent. And the aquatic ecosystems we are talking about, I was completely at sea because I'm at the hills, brought up in the hills, and working in a state like Dehradun. So I was completely at sea, but even then, some of the things which I've been doing are great, really great. But my colleague here was Dr. Saket is not there. You and I, we as people like us in the management, we are in the same team, in the same side. We must work together, very closely together, so that we make a very potent fighting unit. You know? Because we are fighting a very losing battle. As we rightly pointed out, the battle is going to be even more intense in the coming days. The fighting is a very losing battle, and the only weapon we have in our hand is good science. Good science, and the bullets we have is data. Good data, very solid data. And whenever some people challenge us in a political meeting or anywhere, and people are sitting on the opposite side of the chair, in the table, only potent bullet or weapon we have is data, solid science-based data, with which you can throw them. And when you challenge them with the data, they are really flustered because they can't answer that. So I think we are doing a marvelous job of creating data in all aspects. I remember yesterday I was talking to somebody that when we used to come to ARS many years back, the main flagship species of those days used to be the tigers, tiger everywhere. But nowadays we've gone to some other species, I'm glad to hear that. So I'd like to make some comments on one thing is getting feedback, Creating opportunities is one thing, but getting feedback is very important. That how much retention is there. I was very happy to see some of the courses also. They are very particular about retention, how much of retention is there. How much did they learn and are they really there? Because retention is very important in that. And then I've got one suggestion, I don't know whether it will be feasible or not. This Ganga prayers. The Ganga prayers is very important and people are very deeply emotionally attached with Ganga, River Ganga. So can we think of something like honorary Ganga prayers? Honorary Ganga prayers, it would be a very good idea. It's like how about nominating the Chief Minister of Duty as the honorary Ganga Prairie, or maybe the मुख्य जो है क्या सेवक देश का मुख्य सेवक मतलब देश का मुख्य गंगा प्रहरी. I don't know, you can work on that. So with these words, I thank you for giving me this patient hearing and this opportunity. Wish you all the best. Thank you.
Thank you, sir. I would now like to request Dr. Johnson to kindly present a token of gratitude to our chair and coaches for doing such a wonderful job. First, Rategi sir. Thank you, sir. And now to our very own Shivkumar sir. Thank you, sir. We will now break for lunch and be back here at 2 for the next section. Thank you. May I please request the presenters to kindly come and put their talks for the next session as well. And hand over your introduction slips to
Wildlife management has a very strong field component. And I'm extremely happy to see that there is a great amount of field that is. And I'm sure that over the next then presentations, although it's bad, it's economically could not be classified with bird, fish, plants, or something. But it's a wonderful thing. Just wait. Thank you. The first speaker is my big party. He's going to speak about diversity, this guy is delicate, exploring herpetofauna diversity in our Nancy Patel is a PhD scholar at WII. He is currently working on the systematics and ecology of cascade stream forms in the Himalayas. Over to you, Nathan.
Good afternoon, everyone. I think this is going to be the simplest presentation of this ARS. I'm not going to talk about much stats and numbers, but going to talk about the remarkable herpetofaunal diversity. So if you want to do an exploration survey, one of the best places in India is Arunachal, without a doubt. But this is a huge landscape and not easy to start with if you want to do exploration. So in case if you want to start, better to go with the protected area, because none of these protected areas have the proper checklist or the inventory of the herpetofauna. So in our previous studies and surveys, we did cover some of the protected areas, and like one example is, you can see the Savus, that is Abor expedition that we did. But still, some of the areas in the extreme east of Arunachal, like Namdafa and Kamlang, very interesting landscape, is still not covered. So to carry out the exploration survey, we proposed a project to NatGeo, which do support this inventories and expedition research. So I'm going to talk about the findings of this expedition and the past expeditions, result of the past expeditions. So methods are very simple, and I'm going to divide it in two sections, like field data collection and lab analysis. So for field data collection, we try to sample in the peak monsoon, post-monsoon and pre-monsoon in the two seasons, which is like 2022 and 2023. In the COVID, like 21, we could not sample it. And for the field data collection, we do a visual encounter search, so which is very simple, in which we go for the survey in the night and the daytime. We make sure that within 1 hour, how many species we are encountering. So that is visual encounter survey. An opportunistic survey. And the second part is documentation of the specimen. So this is very tricky part, because once we collect the specimen, frog doesn't sit like this. It takes a lot of effort to make the frog sit like this. And we don't miss much frog when we are sampling it. We miss some of them when we are actually photographing them. And once we photograph them, we preserve it like I have shown in the photograph. And we also collect the tissue sample for the genetic analysis. And we also record the natural history observation, like breeding and call and other. For lab work, we do morphometry, molecular analysis, and call analysis. For morphometric analysis, we use vernier caliper, and I'm just giving an example of frogs. So for frog, we take around 64 characters, and it depends for lizards and snakes too. For molecular analysis, we use tissue collected from the specimens. We sequence the mitochondrial DNA, and then we go for the phylogenetic analysis using this method. So once we are done with the phylogeny, we'll be able to know like which clade or which lineage they follow. For call, we use Raven Pro and R packet sound shift. So far in Namdafa and Kamlang, we recorded almost 82 species of Herpetofauna, like 45 amphibians and 37 reptile species. Like for Kamlang, this is the first inventory data, like 15 species of amphibian and 12 species of reptiles. For Namdafa, there has been report of 22 species from 2019 publication, but we recorded almost double the species of what has been reported before. And for reptiles, this is the first inventory data set. So far from Arunachal, we reported almost 80 species of amphibians and 60 species of reptiles. So total 140 herpetofaunal species. But I'm not going to talk about each of them, but I'll take you through some of the interesting ones, like this one. The green tree frog, recently described from Namdafa. So it's very interesting frog, one of the most beautiful frog you can say, and it looks like a bit glass frog from Amazon. So first year we could not record its call or breeding behavior or other data because we had no idea like where to look for the species. But once we recorded it, next year we went for the same site to get some more natural history data. I'll just try to play the song. It plays. Yeah. So this is the call of this species. And same, we got new species of this Arunachal rain snake. So this snake, my guide found like 15 years back. But the second specimen we got like recently. In this trip we photographed it. Before that we could not photograph this. So this snake lives in tiny streams and under the boulders. Also, new species of torrent stream frog, Adicola. This species was named after a tribe from Arunachal Pradesh. And we could not describe this species before we can solve the taxonomic problem, like a redescription. This is also equally important to redescribe the species as to describe a new species. Like suppose one species is like 100-year-old, so they don't have molecular data or color description or color plate photograph or detailed morphological description. So if you want to describe a new species, you need all this detail. For that you need to redescribe the old available species. So we redescribe this species after 150 years, and based on that now we can solve the other taxonomic problem from Indian Himalayas. Another example of this is the only photograph of this interesting snake, Amphiasma piali. This was redescribed after 129 years from Arunachal. Also, one more interesting species like Boiga multomunculata. So this species has earlier considered to be a two different species because it has the two morph, but now we know that it's a single species. And one morph which shares the geographical boundaries with viper, it shares the similar morphological morph with that. Also, one more interesting species, Japalura austiniana. This also no photographic record was available and color description was not available. So this we provided in the publication. Some new country records like Halotus nidogensis and Amelos baibagensis. This apart from their type locality, they don't have much distribution data. So this record helps in understanding their distribution. Like still we are getting not only frogs and snakes and lizards, we are also getting interesting tortoise. Like Manoria impressa was, it is a first country record for this species. Also, these are not new, but maybe new. Salamander and Sicilian, whose identity needs to be confirmed yet. Also endangered species of killbox turtle. And these are the first time recorded live photograph of Philotus namdaphensis and Draco novelli. Before that, it has not been documented. So we know that we did recorded 80 species of Herpetofauna, but still we know that there is a lot more potential, and this list is not complete because some of the microhabitats still need to be covered, like canopies. We have not looked into canopies yet, and high elevation areas like near Vijayanagar and Dapabum, that still needs to be explored. Another massive task is tadpole identification. Like till now we have classified it based on the family level, but we can go into species level in upcoming time. Also the call, we are also generating the bioacoustic data, like we are developing the call library. So once we have the call library, we can actually go for the bioacoustic, passive bioacoustic monitoring. So this will give more data about their breeding phenology and activity pattern, and also about the monitoring, where you can monitor specific species. Yesterday we released one pocket guide, but we are also planning to release more pocket guide for other protected areas of the Namdapha National Park. This will help in developing awareness, and also will help in monitoring the species for the forest department staff. We are also providing the call library with this pocket guide. So one more challenge is cryptic species diversity. Like as I told you before, they look similar morphologically, but they are a group of multiple species. So for that, we need to have large-scale sampling across the landscape. And we don't have one group, we have such 24 groups from this landscape, which holds the multiple cryptic species diversity in this group. So far we have sampled from all this region and collected almost like 3,000 registered specimen. WI is the national repository for biological specimen from the protected area. So we are maintaining and managing it. And we documented almost 330 species of Herpetofauna from this efforts. But it's massive data, and right now we have like 3 dedicated students working on this group. So at least from this three group will get an insights about the biogeography and evolution, and another interesting ecological aspect from Indian Himalayan region. But I would like to highlight some of the conservation aspect too from this landscape. So as you can see, the blue highlighted part is Namdapha and Kamlang Tiger Reserve. And if you can look at the bottom, this region. So this is Vijayanagar and Nandhigram. So this area is surrounded by Burma border, Myanmar border. So if they want to go to the nearest town, they have to go through the national park. They cannot go any other way. So there are 2 ways to go till the nearest town. Either they can go by helicopter ride, which is once in a week, or they have to go by walk. So people in this region, like mostly they are good hunters, but hunting is not a big problem as the cardamom is going to be in the upcoming years. Because earlier they used to take a lot of time to transport the cardamom, and cardamom they sell it at really high price, like 400 rupees per kg. So now once the road is there, once they send 1 truck of cardamom, they can actually buy a new truck once it reaches to the nearest town. So they make a lot of money, and then the land is limited, and they are going to compete for this cardamom with the to cultivate the cardamom with the forest land. And this is not only in Namdapha and Kamlang. Arunachal in general facing a lot of challenges with the developmental aspect like tourism, dams, and also they use frogs as food. So it's the newly described species which they are already consuming in the local market. And we know that we are losing the habitat and losing the species which are not documented yet. And what we are doing is pretty basic. We're just trying to document the species, but it's important. And this is just an attempt to document the unknown diversity before we actually lose them. Thank you.
The next speaker is Mirza. Mirza is going to be speaking about conservation action plan for human and of the Sangai using an integrated approach.
Mirza is currently working as a conservation officer in Campa Sangai project. He has done his bachelor's and master's in biotechnology and has recently completed his PhD in wildlife sciences at Transfer University. Over to you, Mirza.
Yes. So thank you for the introduction. Good afternoon, everyone. Today I'm going to present the progress achieved so far in the Project Conservation Action Plan for Manipur's Pro-Antler Deer or Sangai. This project is being supervised by Dr. Ruchi Badola and Dr. S.A. Hussain. This project is basically an extension of a previously implemented project during 2006 to 2008 in Kebulumjao National Park by Wildlife Institute of India. I would like to start with a glance of how the species was discovered and described. In 1838, during the road construction between Kachar to Manipur, from Kachar to Manipur, during the road construction, Lieutenant Percy Eld, he encountered antlers which he thought that can belong to a new species. But his colleagues told him that the antlers to which it belongs, the species is also present in other areas of the country. So he did not publish that work at the time. He handed over some specimen to his colleague, Captain Guthrie, those antlers actually caught the attention of Maclelland, who was the principal editor of Calcutta Journal of Natural History. He published and described the species as Cervus frontalis in 1840. Later, the species was renamed as Cervus eldi in the honor of its discoverer. Maclelland, this is the very first illustration of Eld's deer by Maclelland, and he described the species as the most beautiful and graceful of all the deer. Coming to the subspecies of Eld's deer, there are 3 recognized subspecies distributed in highly fragmented populations in Southeast Asia. The first subspecies is Rucervus eldi thamin. The population in the wild exceeds around 3,000 individuals. The second subspecies is Rucervus eldi siamensis, whose population in the wild is around 600 individuals. And coming to the Indian subspecies, which is Manipur's blue-antlered deer, or lovingly known as Sangai, the population in the wild is critically low. You can see that the population in the wild is less than 100. However, the population is very well represented in captive populations across 15 zoos in India. Coming to the study area, Kibulamjau National Park, it is the only floating national park in the world, and the floating vegetation, commonly known as Fumdi, is the most important and unique character of this particular landscape. Fumdis are actually soil and organic matter at various stages of decay. The total area of the park is 40 square kilometer, out of which 26 square kilometer are the floating meadows, and open water and hillocks comprises 14 square kilometer. We have identified few factors which are affecting the long-term survival of Sangai in Kibulamjau National Park. These factors include single isolated and small population size of Sangai, increased probability of diseases and mortalities, deteriorating habitat conditions, lack of connectivity for recolonization in surrounding viable habitats, high biomass demand on the park, and poaching and incidental mortalities. Coming to the major threat, the most important threat to not just to Sangai but to the entire ecological integrity of the Loktak Lake is the commissioning of Ethai Barrage in 1983, which was commissioned for hydropower generation and irrigation of at least 24,000 hectares of land. The barrage has brought drastic changes in the hydrology of Loktak Lake and is severely threatening the survival of Sangai. Almost 20 species of flora and several migratory fish species has already been disappeared because of the commissioning of Ethai Barrage from Loktak Lake. With this, the project came up with the following objectives: that strengthening the existing population in the wild in Kibulamjau National Park, establishment of a second population within the state of Manipur, improve habitat condition and protection measures in the park, and involving the local communities in the conservation efforts, along with conducting applied research on the ecology of the species. With this, strengthening the existing population of Sangai in Kibulamjau National Park is very integral, because this is the only surviving population and it is our responsibility to conserve the existing population. So to achieve this objective, we have prepared an integrated management plan that has been prepared and has been released. The plan is proposed for a period of 10 years with a midterm review of 5 years, and collaborative implementation of the management plan is in process in collaboration with Manipur Forest Department. In the management plan, we have identified priority zones for habitat management and restoration, regular monitoring of habitat conditions and distribution patterns of Sangai associated in Kibulamjau National Park. We have identified zones like minimum intervention zone, restoration zone, tourism zone to restricted tourism activities within this zone. We have identified areas for tall grassland management and priority intervention area for consolidation of Fumdis. This is the scenario of water level allocation in Loktak Lake provided by Visa in 2011. They have proposed 3 scenarios, in which scenario one is mimicking the natural regime of the lake. In scenario 2, multiple objectives that will be benefiting the hydroelectric power generation and conservation of Sangai as well. And the scenario 3 is business as usual. This is the lean season, which extends from March to June. The natural hydrological regime should reach 766 meters. The water level should be 766 meters to maintain the replenishment of Fumdi, because Fumdi is used to settle down during the lean season, get replenished, and then with the onset of the monsoon, they, because of the buoyancy, they again start floating. So this is the situation in the field. This is the water level data we have collected from Ithai Barrage since 2006 to 2010 and 2016 to 2021. You can see that water levels during the lean season are constantly maintained near about 768 meters, which is imposing serious threat, which is altering the hydrological regime of the Loktak Lake and ultimately deteriorating the habitat conditions in Kibalamjo National Park. Coming to the pallet distribution of Sangai, we have classified the pallet density of Sangai in high, medium and low zones. We have surveyed the entire park and this is a decadal study. You can see that in 2006 and 8, the Sangai distribution was almost there in each and every corner of the park, like in the most of the areas of the park. However, in 2017 till 2021, we can see there is a northward shift. The areas highlighted in the red, there is a northward shift in the distribution in the high pallet density areas of Sangai. This is because the northern zones have high thick fumdi and the central zone is filled with tall grassland, and the southern zone, the fumdi thickness is very low, so most of the Sangai population is totally restricted in the northern zones of the park. This is another critical objective of the current project, that is establishment of a second population in the wild. To achieve this objective, we have prepared an action plan for conservation breeding with experts from Smithsonian Conservation Biology Institute and National Institute of Animal Health. We have also put up the matter in 6th and 7th State Board for Wildlife meeting, and the committee has recommended to declare the proposed second home site, that is Pumlenpat Thangamandam Reserve Forest, as a conservation reserve. Also, we are developing the conservation breeding center at Kibalamjau National Park, and right now we have completed the earthwork and we are prepared with the design of the enclosures. And once the situation resumes in Manipur, we are hopeful to resume the work, resume the development of the conservation breeding center. Coming to the population estimation of Sangai, it is very important to know how many Sangai are there, because each and every management intervention is dependent on the numbers. What number of Sangai are there? And to achieve this, we have conducted collaborative population estimation surveys in 2019 and in 2023 during the month of March. And we participants from local colleges, students, participants from NGOs, we provided them training how to identify Sangai and hog deer, how to handle the equipments and how to perform the survey. So these are the density estimates. You can see not much good news here. The species is nearing extinction. You can see that from 2006 to 2008, the population, the mean estimated population was around 90 to 92 individuals. However, in 2019, the population came up to 76, the mean population size. And the recent estimate states that the population size, the current population size is 64 individuals with a minimum of 32 and a maximum of 105 individuals. You can see the population trend also was showing in 2019, it was showing a decline of 1% per annum. However, in 2023, the decline increased to 1.9% per annum. These are the density estimates of hog deer. You can see a steady growth in the hog deer population. According to the estimates of WII, in 2006 to 2007, the population was about 60 to 65 individuals. However, in 2019, the population almost doubled and it reached a number of 123 individuals. Again, followed the recent population estimation, the current population of hog deer is 175 individuals. And according to the population growth trend, the population was showing 5% increment, 5% growth in 2019, and now the population is showing a growth of 6.2% per annum. This is further imposing a threat because the increasing population of hog deer is directly can be a direct interspecies competition for Sangai. Coming to the conservation genetics, we try to look into the divergence and genetic diversity status of Sangai, the population genetic structure, and also the demographic history. We have used tissue samples and fecal samples, and this is the first account of sequencing the complete mitochondrial genome of Sangai from the wild. Complete mitochondrial sequence is available, but that was from captive population, so we have tried to sequence the complete mitochondrial genome. And we have estimated this is a time calibrated chronogram extending from present time till 18 million years in the past, and we have calibrated the change in the eustatic mean sea levels at the base of the tree. This is a fossil based calibrated chronogram. We observed a divergence of two simultaneous diversification of two phylogenetic lineages. And coming to the diversification of the H. deer subspecies, it was evident that the Indian population, the Indian subspecies, is the primitive compared to the Southeast Asian subspecies. And the diversification is happening in the periods of low sea level, which was facilitated by emergence of land bridges between the islands of Southeast Asia and mainland Southeast Asia. And primarily the diversification and the dispersal occurred using Sino-Malayan route from Southeast Asian island to mainland Southeast Asia, and from Siva-Malayan from Southeast Asia to mainland India through Siva-Malayan route. Coming to the population genetic structure, you can see that the wild and captive population is showing substructuring. However, the genetic diversity of however the FST values are low. Also, the genetic diversity in the captive population is comparatively low than the wild population. The observed heterozygosity is also low. And interestingly, this is also a critical factor. The estimation of effective population size of Sangai, we have estimated the effective population of size, and it comes to 7.5. To avoid inbreeding depression, an effective population size, recommended effective population size is 100, and to avoid and to ensure long-term survival of the species, an effective population size of at least 1000 is recommended. However, you can see the effective population size of Sangai is 7.5, which is critically low than the threshold to avoid inbreeding depression. Coming to the demographic history, we tried to plot the demographic history of Sangai. This graph extends to from present time till 5000 generation in the past, with a generation length of 6 years. That accounts for 30,000 years in the past. So you can see that the population from 5000 generation till 3000 generation was almost stable. However, we can see an increase from 3000 generation till 500 generation, and increase the population expansion event is happening. This was followed by the post-glacial precipitation. The origin of Loktak lakes is believed to be around 25,000 years ago. So with the increase in the habitat availability, the Loktak lake occupied entire Manipur Valley. The Sangai got opportunity to inhabit new areas, and the same is being reflected in the population expansion event between this duration. However, since last 1000 years, or you can say from the 500 generation in the past till present, the population is showing a decline. This period accounts for 1000 years in the past. This corroborates with the shrinking of Loktak Lake area. The population of Sangai expanded because of the increase in the Loktak Lake area, and now it is shrinking because of the shrinkage in the Loktak Lake area, and also the evidence of beginning of paddy cultivation and human settlement in the Manipur Valley. This is resulting in decline in the effective population size of Sangai. Coming to the veterinary component of the project, we are screening the fecal pellets of hog deer and Sangai for the presence of endoparasites in and around Tibulamjau National Park, and we have identified ova of amphistome and Sangai in the fecal pellets of Sangai, and also we are conducting regular ring vaccination come health camps for livestock in collaboration with the State Veterinary Department and Manipur Forest Department. We are also working on rescue and rehabilitation of wildlife. As of now, we have successfully rescued and rehabilitated 21 animals, including hog deer, barking deer, Southeast Asian box turtle, barn owl from different locations of the park. Coming to the carcasses encountered during the field survey, there are so many Sangai and hog deer carcasses we encountered during our transits in the park. We transport with assistance from the forest department these carcasses to the range forest office, and in collaboration with Manipur Forest Department and veterinary department sometimes, we conduct post-mortem of these encountered carcasses to identify the cause of the death and to collect samples for disease investigation. You can see we also observed the dog bite wounds in one female hog deer. This is also a threat to the population, to the wild population of Tibulamjau. We also translocated Sangai from Langol Conservation Breeding Center to Manipur Zoological Garden for display purposes. 4 Sangai individuals were successfully translocated, including 2 males and 2 females, and the relocated individuals are adapted very well, and currently the population size is 9 individuals. Involving the local community is also a critical aspect of the project, as the local believe that Sangai is the binding soul between humans and nature. We are following 2 approaches. We are conducting research studies also, and we are working on implementive studies also. So as a part of the research studies, we have identified the livelihood of the communities, and 54% of the households are dependent on park resources, including fishing, vegetable collection, fodder collection, fuel wood collection. Also, an analysis of the fishing and vegetable extraction showed a increase of almost more than 180% and for vegetable more than 80% increase. In the last 2 decades, from 2009 to 2019, this much increase has been observed. This is for commercial purpose and for consumption purpose. Fodder and fluoride extraction has been decreased. We are also working as a part of the implementive actions of our project. We have trained more than 250 local women in institution building and self-help group formation, and we are converging them with Manipur State Rural Livelihood Mission. And also we have established 13 active self-help groups, and we are developing forward and backward linkages of their product. We have also established a souvenir shop at the gate of Kibulamjam National Park, and livelihood planning and further community mobilization in the area is ongoing. These are the efforts we have provided. Sir, just 2 minutes. So we have conducted community outreach and consultation and conservation education programs, capacity building, trust building activities to garner a larger support. These are some to build a larger constituency for Sangai conservation. We are working on information dissemination in forms of posters and pamphlets, and these are the research publications and reports from the project. And with this, I would like to summarize that the Sangai population is showing a declining trend, the habitat conditions are deteriorating, and the priority is to establish the conservation breeding center, and we are trying our best to establish the center, but given the socio-political situation in Manipur, we are lagging behind. But we'll resume the development as soon as possible, and there is a pressing need to regulate the water levels in Loktak Lake, and also effective implementation of the management plan. If we want to save the Sangai, we need to take this action immediately. With this, I would like to acknowledge the following people. Thank you so much.
The next speaker is Sushi. She is going to talk about chasing the unicorns, evolutionary history, genetic health, and their conservation.
She completed her master's in zoology from University of Calcutta. She joined WI in 2019 and worked on studying the food habits of tigers across the arc landscape. Currently, she is a PhD scholar working on the conservation genetics of Indian rhinos. Over to you, Shri.
Thank you, Prashant. Good afternoon, everyone. Today I will be discussing about the conservation of Indian rhinos, and what more better day than on the World Rhino Day itself. The Indian rhino belongs to the Rhinocerotidae family, along with its fellow Asian members, Sumatran and Javan, and two African species, black and white rhino. This family had a complex evolutionary history. The African and Asian species diverged around 16 million years ago, and among the Asian species, Sumatran is the oldest one, and the rhinoceros species that has the Javan and the Indian rhinoceros diverged around 4 million years ago. What led to these diversifications was the early Holocene global warming that resulted in range contraction, and the trend got accelerated because of human interferences leading to local extinctions. Once, all of the three Asian species were found together in the northeast of the Indian subcontinent, but the range got restricted to only the protected areas, such that the Indian rhinos are only found in the 11 protected areas of India and Nepal. Now, it is to be noted that all of these protected areas are isolated and fragmented and have no connectivity among themselves. Literature suggests the identification of potential habitats for the population management. Now, in order to do so, few of the factors should be important, such that the habitat, demography of the species, identification of source population, and the genetic status. To identify this, we use non-invasive sampling. We used swabs from the fresh rhino dung piles, and tissue samples were provided to us by the respective forest departments. Using this non-invasive data, as we know, the population had a continuous distribution, but when and how this population got fragmented, we do not have the idea. For that, we studied the evolutionary process and to know the current genetic status. For the evolutionary history, we used 111 unique rhino samples collected across the 7 rhino-bearing parks of India. That is the Dudhwa, Gorumara, Jaldapara, Manas, Povitora, Orang, and Kaziranga. Out of this population, Dudhwa is a reintroduced population from Chitwan in Nepal and Povitora in India. Manas is also a reintroduced population from Kaziranga and Povitora. As we are studying the ancient history, we used mitochondrial DNA, which is a powerful tool uncover all the historical evidences. We generated whole rhino mitogenome data for the first time from the wild rhinos. We then identified nucleotide variations from those and then generated about 2,500 base pairs of data from the 111 samples covering all the variations. We then mapped these genetic variations or these are known as the haplotype networks, and found that the Assam retains majority of these genetic variations. Now in this figure, each of the circle represents the unique haplotype and each of the color corresponds to the 7 rhino parts. Combining all the phylogenetic analysis, Bayesian analysis and the haplotype network, we can say that Indian rhinos consist of 3 maternal clades, that is Assam, UP and West Bengal. Now, an interesting thing about this figure is that, as I told you earlier, the population in Dudhwa is a reintroduced one from individuals of Povitara and Chitwan, Nepal. So the figure was supposed to look like this, that is green depicting Povitara and pink depicting Dudhwa. But this wasn't the case. So we were wondering if there was any sampling biasness or the population in Dudhwa was actually showing signals from Nepal. For that, we had been provided a sample by Bihar Forest Department that was collected from Valmiki National Park, which was supposed to be from a dead rhino carcass that had come there during the flood season. We then generated sequence from that sample and aligned that with that of our Dudhwa sample and found that it had the exact match. The reason for this lies in the pedigree data of Dudhwa. The founder population in Dudhwa, when it was introduced in 1985, consisted of 4 females from Chitwan in Nepal and 2 male and 1 female from Povitara. In the next generation, females from Povitara gave birth to daughters, and females from Chitwan gave birth to daughters in the next generation, and female from Povitara gave birth to son. And as we know, mitochondrial signatures are inherited maternally. Thus, we can say that rhinos of Dudhwa represent maternal signatures of Chitwan, Nepal. Now, once we had known there are 3 different clades, we wanted to know when and how these clades had diverged into the Indian subcontinent. For that, we used available fossil data and mutation rates that gave us the estimates of time divergence. In this figure, the x-axis shows time in million years ago, and all of the shaded region are the paleobiogeographic history of Indian rhinoceros in the Indian subcontinent. Point A here shows that the Indian rhinos have diverged around 0.95 million years ago. That corroborates with the emergence of modern mammalian ancestors into the Indian subcontinent. This is followed by the movement of rhinos away from Assam along the Shivaliks, which is also evident in other species like the elephas and Mandyaks. The movement of rhinos got restricted in the Holocene climatic period due to monsoon intensification and dominancy of grassland habitat types. This was also the time when other grassland dependent species like the swarm deer, their movement were also restricted at this stage. Now this is all the information of rhinos in the Holocene time period, that is around 10,000 years ago. Now if we come to the Anthropocene, looking at their fragmented population, there are many factors driving that, such as the habitat fragmentation and sports hunting in the mid of 18 to 1900s. Their population further declined in 1950s after the discovery of DDT and malaria control in the region. Their population hit a setback in 1980s when around 46% of their population were lost because of consistent poaching pressure and socio-political unrest. This led to the local extinctions from Tarai and Brahmaputra plains. The story of the revival began in the early 20th century after the passing of Wildlife Protection Act and many other conservation programs. This led to increase in their population from few hundred individuals to currently 4,000 individuals in the wild. Now, the conservation story of Indian rhinos in India is known to be one of the most successful conservation stories. Now, out of those 4,000 individuals, majority of them are found in India, but it is to be noted that these are all isolated populations. And if we look at this from a genetic approach, we can see that over the time the population has become inbred, and this would lead the population to not face any stochastic factors, be it anthropogenic or natural. For that, we studied the current genetic status. We used integrated multiple clustering approach to identify true genetic clusters or K using microsatellite markers that give us the idea of recent population history using 504 samples. The structure analysis gave us K equals to 5. corresponding to all the 7 rhino parks. Now, as we see, we are getting 2 different results based upon 2 analyses, that is 5 and 7. So, which is the true one? But in both of these 2 analyses, there are 4 common clusters: Gorumara, Joldapara, Povitora, and Kaziranga. The signals of Dudhwa, Manas, and Orang is different. Now, in order to resolve that, we use spatial autocorrelation analysis, or the SPCA. This analysis gives us the significance by pairwise comparison between 2 parks if they are true clusters or not. Now, among all these, Geneland was true in identifying Orang as a different cluster. SPCA identified Dudhwa and Povitora to be a different genetic cluster. Now, Manas is not a true genetic cluster as it shows its signals from the parent population, that of Kaziranga. Summarizing, we can say that Indian rhino consists of 6 genetic subpopulations, that is Dudhwa, Gorumara, Joldapara, Kaziranga, Povitora, and Orang, and Manas is showing mixed signatures from its source population. Now, once the 6 subpopulations were identified, we wanted to know how healthy each of the current population is doing. For that, we use genetic health parameters like the genetic distance, allelic richness, and population-specific FST or FIT. Here, I would like the audience to keep in mind what the positive and negatives of each of these indices mean. The negative value of genetic distance means that it is contributing more towards the gene pool, and positive meaning less towards the gene pool, whereas it is opposite for the allelic richness. The positive means that the population is contributing more towards the gene pool, and negative meaning it is contributing less towards the gene pool. FIT is an indicator of an inbred population, where 0 means the population is not inbred and 1 meaning the population is inbred. So our expectation was for a healthy population, the population would have negative GD, positive C, and low FIT value. Coming to the results, this table is arranged in an increasing order of FIT value. The population of Kaziranga and Manas shows that they are in good genetic health condition, which is evident by the negative GD, positive C, and FIT value. The population of Orang and Povitora shows moderate genetic health. Although Orang is a different genetic cluster, it is not unique enough to add anything to the allelic diversity. The rhinos in Povitora the rhino density in Povitora is so dense that the population has become inbred, which is evident by their FIT value. The population in Dudhwa shows poor genetic health. although these have maternal signatures from Nepal, which is adding to their positive allelic diversity, but during their reintroduction, it was only a single supplementation event, and there has been no introduction of new gene pool, and the population has become inbred. West Bengal population, that is Joldapara and Gorumara, are in urgent need of genetic restoration. Now, conservation action plan should not be one shoe fits all. Thus, we recommend conservation action plans at independent park level, considering independent genetic health of each of the parks. For the population of Assam, Manas and Kaziranga are doing well. Now, Orang National Park acts as refuge for rhinos during the flood season coming from the Kaziranga National Park. However, grassland encroachments have lost the connectivity between the two. Thus, we suggest to restore the grassland patches between these 2 populations to ensure the maintenance of metapopulation. The population in Povitora shows moderate genetic health. Now, this is because there are over 100 rhinos living in a small habitat patch of 16 square kilometers, and the habitat of Povitora has reached its carrying capacity. For the population of Dudhwa, the rhinos in Dudhwa live in 2 small enclosures of about 9 square kilometers and 14 square kilometers. Thus, we recommend to increase in their habitat size. And also, periodic supplementation of individuals from healthy source population would ensure new genetic pool into the population. Now, for the population of Gorumara, this population was severely affected in the 1800s because of habitat fragmentation, and there exists no natural corridor between the 2. Although they belong to 2 distinct genetic clusters, but they are doing genetically unhealthy, and we suggest the translocation of individuals from healthy source population like Kaziranga, and also translocation of individuals from Povitora would also serve in bringing the allelic richness. Our conservation implication include the future survival of Indian rhino is based upon translocation and reintroduction programs. Translocation of individuals to new identified potential habitat should be considered. Periodic supplementation of founder members for population management plan should be done, and genetic health analysis would help in facilitate prioritizing conservation action plans at independent park level. This work is a collaborative between Ministry, WWF and WII called Rhodey's India Program or the Rhino DNA Indexing System, whose way ahead is to expand this work to the transboundary region of Nepal and generation of in-depth population level information. With this, I would like to acknowledge the following people, and leaving the stage, I would want everyone to have a look at this small video, which we encountered in the field. Thank you.
Thank you, Shashi. Next speaker is our faculty colleague, Dr. Shomita. She's going to be speaking about the genomics studies on Rusty spotted cat.
Dr. Shomita is a senior principal scientist at Dugong. She did her master's and PhD from WII and postdoc from NCPS. She works largely on small cat ecology and genetics. Over to you, Dr.
Thank you. So, good afternoon, everyone. So, this study on the genomic aspects of the rusty spotted cat is a third in a series of projects that was funded by the Maharashtra Forest Department. It all started with a survey in Sangai National Park in Mumbai, where with the help of citizen volunteers, we conducted a survey for small cats because they didn't know where the small cats occurred within the park. Most of the focus was on the leopard. And we generated data. This is a map of the distribution of the rusty spotted cat in the park. And at the same time, they also had a captive breeding center for the rusty spotted cat. I think Dr. Barucha is aware of that. He was very interested in rusty spotted cats. So they have a captive breeding center over there. And they started the captive breeding center because over the years, there were many little rusty spotted cat kittens and even jungle cat kittens that were brought from neighboring areas by well-meaning farmers especially, because while they were harvesting the crops, they found these kittens and they brought them to the forest department. So when we started the project, they had around 9 rusty spotted cat individuals in captivity, and they were spread across all ages. But if you look at the conditions that they were kept, this is an enclosure, it's pretty terrible. So one of the things they wanted to do was it was kept near a large cat enclosure, and of course they were not breeding. And so one of the things they wanted to do was they wanted to enhance this facility to international standards. And so we also helped them conduct a workshop where we trained their forest staff in captive rearing and basically captive care. You know, whether it's nutrition, we even helped them design their enclosures. And they now have a prototype of a very beautiful enclosure that can hold rusty spotted cats, not just for captive breeding. And then we wanted to find out, do they really need captive breeding for this particular species? So like all cats, this cat is also very rare. It's nocturnal, it's solitary. It is the smallest cat in the world. It weighs only around 1 or 2 kilos. Okay, and it is found, its main diet is rodents, which we found out from a study in SGN. And very little is known about this cat actually in natural conditions. And it is endemic. What is really interesting is that it's endemic to India, Sri Lanka, and Nepal, only 3 countries. And as you can see, about 80% of its population is found in India because it's very widespread in India. Very interestingly, again, it is a cat that does not tolerate extremes. It does not live in the hot deserts. It does not live in the cold deserts. It does not live in very wet northeastern forests in India. So what it's majorly associated with is deciduous forests throughout peninsular India. And that is where the habitats are very severely fragmented right now. So what we did is, initially, this is not part of this study, we had conducted this niche analysis for the cat, for this particular species, and we went back into time to see how did the niche of the cat, what we look at currently, how was it distributed over the Indian subcontinent in the past, in the Quaternary period, because the Quaternary period is a time in the geological history where even today, many distributions of species today are actually explained by the distributions in the Quaternary period, because the Quaternary period was a period of very large climatic oscillations, what we know as the ice ages. So the LIG, or the last interglacial, which is 120 years ago, the climate in the subcontinent was warm, the subcontinent was very richly forested, and it had a very strong southwest monsoon. Then you come further towards current time to 22,000 years ago, which is the last glacial maxima, which a lot of us are familiar with, which we call as the Ice Age, where the ice got formed in the northern hemisphere and in the Himalayas. It sucked up all the water, and the Indian subcontinent became really dry, the peninsula region, and the forests opened out into grasslands. So you can see a very contrasting habitats that formed because of climatic conditions. And then you have the mid-Holocene, which somebody spoke about in the previous talk, which is around 6,000 years ago. And you can see how the rusty spotted cat distributions, the climatic niche, this is not the distribution, this is just the niche during this time. It was very focused in the LIG towards southern India. The yellow parts are the parts of very high probability of the niche. Around LGM, it kind of diffused, but it spread out over the country. Around mid-Holocene, again, it kind of spread, it kind of focused towards the south. And then in current, it is actually much less focused, it's kind of diffused. And you see the niche has also kind of become less, it's kind of, like I said, it's diffused, it's not focused. And again, when you move into the future, what we predicted for 2070, okay, and you look at the very optimistic scenario where, say, you protect all the areas, the habitats of the rusty spotted cat, and then you look at the business as usual scenario, they predict the same. They predict a very stable climate from the 2000, from the current until 2070. Now, you can't go back into time to see whether this is possible or not. But there is one way you may be able to look at how compare these maps, at least the quaternary period, and tell whether this actually looks like what it would have been. And that is by looking at DNA. Because DNA gives you a history of the past. And the objective in red is what I'm going to be talking about today, to explore the demographic history of the rusty spotted cat back in time, okay, in the quaternary period, and to understand how the climatic fluctuations have shaped its distribution. So for this, like I said, we needed very good DNA for this. And I'll tell you about that a little later, about the method we used. So we got, like I said, there were 9 individuals in the beginning when we started the work. By the time we actually started sampling, there were only 2 individuals left. All the others had died. And we got 3 to 5 ml of blood from each of those individuals. They were 2 sisters. They were called Riddhi and Siddhi, and they were brought from Kathraj, Pune, and they were hand-reared. And with the help of the park veterinarians, we collected blood and buccal swab samples, and it was immediately couriered to IISER Tirupati, where my collaborator Nandini Rajamani works. And there, her students extracted the DNA, and then it was sent to Ahmedabad to a sequencing firm called Newberg, where it was sequenced on the Illumina platform. And then the sequence data was then sent to IISER Bhopal, where my other collaborators, Dr. Nagarjun Vijay and his student, Dr. Ajinkya Patil, they actually analyzed the further analysis. They assembled the DNA and they did further analysis, which I'll be talking about today. And the analysis was done through a standard bioinformatics platform and pipelines, which is normally used for such analysis now. And all the graphs that I'll show you have been bootstrapped 100 times. So this is how the blood was collected and the buccal swab samples. The cats were basically caught in a mesh, and they were not anesthetized, and the veterinarians took the buccal and blood samples. The entire exercise for sampling took just about 5 minutes. So now you've seen in the previous example how they had samples from hundreds of individuals, and they addressed small portions of the genome. Now, the PSMC, or the pairwise sequentially Markovian coalescent method, it's very suitable for really rare species where you do not have access to many samples, because what it does is it just needs one genome. And it looks at all the heterozygous sites in the genome, and it looks at how these alleles, so each locus will have two alleles. If it's heterozygous, obviously the alleles are different, and it will run across the genome, and it will look at how these alleles coalesce or converge to a common ancestor. So it's obvious that if you have a small population that is related, you will converge back into time faster. Okay, so the coalescence events are negatively correlated to the what is known as the effective population size. Now, the effective population size is not your census size. It is simply the number of, very simply put, it is number of males and females, breeding males and females, who have contributed to the genetic pattern that you see. Okay, it can be larger than your census size, especially if it's coming out of a bottleneck, and it will be small if it is going into a bottleneck. So the minute when you look at this, the effective population size, and when it's going, when it grows smaller, you know that the populations are actually dropping. Yeah, it's going through a bottleneck. And that's what this analysis does. This analysis actually looks at the bottleneck history or the expansion history of a species, of a population. So the results, when we compare the rusty spotted cat genome size, it compares really well to its closest relatives, that is a fishing cat and a leopard cat. And then we harvested the what are known as UCEs, or ultra conserved elements. These are points, little fragments of the genome right across the genome, and they are really, really informative for phylogenetic studies. Okay, and we could harvest some 3,000, more than 3,000 loci, and with that we built a phylogeny which supports the already existing phylogeny of cats, where it shows that the rusty spotted cat is at the base of the Prionylurus group, and our estimates of divergence is a little higher than what was estimated earlier. We estimated a divergence of 7 million years when the rusty spotted cat split from the fishing cat and the leopard cat. Now, coming to the PSMC analysis, this is what the PSMC graph looks like. So if you look at it, the x-axis is time and past. It goes from the current, that is around 5,000 years, until 2 million years. And if you look at it, and we use mutation rates that are usually used for cats in literature, what we found. And we use a generation time of 2 years, that is the first breeding time for an individual rusty spotted cat. We estimated it around 2 years for a cat of that size. And if you look at it in the early Pleistocene, the early Pleistocene was again a very cold, open area in the Indian subcontinent, and the population, effective population size of the rusty spotted cat is very low. And it climbs up and it reaches the LIG, and a little after the LIG, it has peaked. So the effective population size peaks at, a little between the LIG and the LGM, and then it comes crashing down into the LGM where it is at its lowest. Now, in an analysis like this, beyond the LGM or around 10,000 years into the current, the analysis doesn't give you very robust results. So it will give you really good results until the LGM. And as I said, in the LGM, the forests had opened out into grasslands. And now if we change the generation times, we see that the pattern is the same. If you increase the generation time, your effective population size drops, which is understood. And if you change the mutation rate, again, the pattern is more or less the same, but with a higher mutation rate, it shifts a little bit towards the current. How does it compare with other cats? There has been similar studies have been done with neotropical cats, because that's where there are many other small cats that occur in South America. And you'll see again similar patterns. The northern tigrina, which is a forest-dwelling cat, it has peaked around the LIG, and the Jeffries cat, which is an open area living cat, you'll see the PSMC graph, which has actually risen around the LGM because it needs open areas. And similarly for the other two cats, the Pampas cat and the Margay. Margay is a forest cat. Again, you'll see that its effective population size is higher during the LIG, and the Pampas cat, the effective population population size is higher, it will be LGM. So they're contrasting patterns. With the large cats, again, we see that it's kind of related to the ecologies where you'll see the leopard is between the LIG and LGM, it has peaked, and the lion is around the LGM, and then, of course, the large cats plummeted once the humans came in. What are the caveats in an analysis like that? Is that when you sample, if you're sampling from one area, if your populations are fragmented and they're structured genetically, that is, you do not share alleles between the populations, don't really share many alleles between each other. If you sample from just one population, you'll have a signature of bottleneck. And if there is even a little amount of migration or mixing happening, and if you pick up alleles from the other population, even in this population, you'll see a signature of expansion. So you have to be careful that your populations are not structured, and that is why sampling from many different regions across the range is very important. Now to conclude, this is the first genomic level information available on the rusty spotted cat, and this is which is endemic to the Indian subcontinent. This is the first genome of a cat that has been generated from an Indian lab. And we've seen that the climatic events in the Quaternary period have caused changes in its effective population size, though the niche analysis shows a stable population. Now, captive breeding should be initiated only if we know if these populations are fragmented. We should not initiate captive breeding if the populations are not fragmented or do not require it. Okay, that is really very important. And for this, we need more genomic level studies on species like the rusty spotted cat and also other small cats. So permits, one of the ways we could go forward is to have permits for accessing samples, from roadkills. There are many small cats that are killed in roadkills. We miss out all that information. If there is a way to collect those samples or a protocol where these samples can be sent to different labs, I think we would really have very enhanced information. And a genomic database for our rusty spotted cat individuals brought to Sangai National Park or any other place should actually be initiated. We have a few publications from the previous projects, and these are my acknowledgements. I thank everybody who's listed over here. Thank you very much.
Thank you, Shomita. The permission of session said we are going to take a couple of minutes break. So there is a small technical glitch and the problem. So we'll take